Hello everyone and welcome to today's session on linear and logistic regression tutorial by Intellipaat. Linear regression and logistic regression are the two famous machine learning algorithms which come under supervised learning technique. Since both the algorithms are of supervised in nature, hence these algorithms use labeled dataset to make the predictions. In this session, you will learn all about logistic and linear regressions. So without further wait, let's check the agenda for the session. But before we begin with the session, please subscribe to our channel and press the bell icon so that you never miss any update from Intellipaat.
So before starting with linear regression, just wanted to understand, like, have you anytime heard about linear regression or maybe any other regression techniques? Just want to know. Anyone heard or anyone worked on it? Okay, fine, very good, very good. So that you just have heard about it and all. So any idea what is linear regression in your terms, simple terms? If someone can tell me. Okay, it produces a best fit line. Okay, anything else apart from that? Apart from best fit line, anything else you are aware? Best fit line is correct. Anything else? So we will learn linear regression today, but before that, just wanted to know, like in case if you are aware of it, x and y, correct? Anything else apart from these? An output with the variables, correct? So y is equal to mx plus c, correct? Okay, fine. So anyone want to take another chance? I'll just probably give you one more chance. Independent values are related with dependent, which tells the relationship between two variables. Correct. Independent values related with dependent variable. Correct. True. So now, having said all this, we will go ahead and then see how exactly these things are working, right? So what is the base and how exactly these things are working? So how do we do this in going forward, all these things? So whatever you said right now, all of them are in a way correct, right? I can't say that is 100% correct, and at the same time I can't say it is 100% not correct also. So in a way what you are saying is right, but it is not completely right. You're getting my point? What you're saying is right, but not 100% right is what I'm trying to tell you. Having said that, now I will tell you what is linear regression. We will understand it from beginning and then how it works. A basic first level understanding we will get. Linear regression is a very very large topic, but I will give you introduction to linear regression from where you can pick up and then go deep dive more deeper to an extent where you find comfortable, right? So what is linear regression, how it works, I'm going to tell you, right? So linear regression using Python. So basically, what do you mean by regression, right? Today is completely theory session, so I want you to focus. I want you to understand this theory concepts very well, so that it will be useful whenever you are going to check for the further sessions, right? So understanding this theory is very important, so that all of you will be able to get a very good conceptual understanding, and then all of you know code you can anyway somehow you can practice. So that is the something, right? So coming to what is regression. So regression is basically a technique of finding the relationship between two or more variables, right? So whenever you try to find a relationship between two or more variables, we call it as regression. And what is this linear regression? Is nothing but, some of you said, change in dependent variable is associated with the change in one or more independent variables. So what we are trying to do is, let us say I have multiple let us say I have one independent variable and one dependent variable, right? We will give examples also, but just now just understand this. So I'll give you some examples also. You have one dependent variable and one independent variable. Now what this linear regression does is, it will find a relationship between that dependent variable and independent variable. So how both of them are related. So that is something that we are going to check. Right? So let me just take you to the next slide. So you can see here, regression is a technique that displays a relationship between x and y, correct? So what is x, what is y? based on these, it will give you a relationship. So whenever you have a variable x which is increasing or decreasing, you will have a variable y somewhat related. So as you can see in this example, as the temperature drops, people use more sweaters. So which means this is a negative relationship, correct? When temperature keeps on reducing, the number of sweaters keeps on increasing. And when the number of sweaters keeps on increasing, I mean, when the temperature keeps on increasing, the number of sweaters used by people keeps on decreasing. So this is one such example. So now I'm just explaining it to you how exactly a regression is being constructed. So what exactly is regression? So it is a technique to find out. I mean, don't worry about the definition that is written here. What I want to tell you is, so linear regression is a technique which gives you a mathematical relationship between your dependent and independent variable, right? So regression is a technique that gives you a mathematical relationship between your dependent and independent variable. Is this clear to all of us? Just simple basics I'm telling you. Hmm? Now we will go into a little detail. So some of the examples of regression. So what are all the examples of regression we have? Let us say temperature versus number of ice creams sold in a store. So let us say the temperature keeps on increasing. During summer season, more ice creams will be sold. If the temperature drops, the sales of ice creams will come down, right? So that is the important thing. So with temperature, you will be able to see how many ice creams are sold or not. If temperature is increasing, sales will increase. If temperature is decreasing, sales will decrease. So that is a good example of positive relationship. So when temperature increases, sales increases of ice cream. So it is a positive relation. Inches of rain versus new cars sold. So I don't know how rain and cars are related, but somehow they could be. So daily snowfall versus number of ski visitors, which means whenever there is more snowfall, the people come to ski. Ski means like they have this skiing board and all that, and then they do the skiing on the snow. So as the snowfall increases, the number of ski visits also increases, correct? So now there is one thing that I will tell you. All of you know what is skiing, right? Is there anyone who doesn't know what is skiing? All of you know what is skiing, right? Yes, no, okay. So now there is one thing that you should understand. Just keep this skiing example in mind. I will tell you in the future. There are some limitations of linear regression. I will tell you that. But keep this skiing example in mind till then. Okay. So these are some of the examples of linear regression. So now, what are all types of regression that we have? There are multiple types. There are so many types, but major ones are linear regression and logistic regression. So basically, what is linear regression? What is logistic regression? We will see in few minutes. But whatever regression that we use, most of it is linear regression or logistic regression. So why do I need linear regression? Why do I need logistic regression? All of that I will tell you now. All right. So you can see here the basic difference between a linear regression and logistic regression is a linear regression helps to solve the continuous variable data. So whenever you have independent variable and dependent variable, both of them should be continuous. Correct. So you need to understand this. Both the independent variable and the dependent variable, both of them should be continuous in the linear regression. Whereas in logistic regression, it can be a categorical variables. So anything, even though your target and other things also can be categorical variables, right? So basically linear regression and logistic regression, that is the first main important thing. Next thing it solves a regression issue. Linear regression will solve a regression issue. So what do you mean by regression? I told you regression is nothing but finding the mathematical relationship between two variables. So that is regression. So by using linear regression, what you do is you find a mathematical relationship between two variables using a linear line, like a straight line relationship. So that is your linear regression. Logistic regression, what it does is it will try to solve a classification problem. So basically a classification problem means a 0 or 1. Since it's a categorical variable, it tries to solve a classification issue. So in linear regression, you have a straight line. In the logistic regression, you have a S curve. So we will see what is this S curve in logistic regression when we start with logistic regression, but linear regression is a straight line, so which we are already seeing. So this is the basic difference between linear and logistic regression. Okay, fine. So basically in this particular session, what we are talking is linear regression, simple linear regression, where we are trying to find out a mathematical relationship between two continuous variables. So in the two continuous variables, one is an independent variable and another is a dependent variable. So basically we have two types. One is independent and one is a dependent. So let us say, for example, in our temperature and sales of ice creams, which was independent and which was dependent? Can you tell me? Temperature and sales of ice cream. Sales is dependent, exactly. Temperature is independent, correct, true. So now why it is? Because see, if you always, if you can remember, sales is dependent on temperature. Temperature is not dependent on sales, correct? So sales is a dependent variable. Exactly. So what you said is right. So here also in our example, we are going to see this, how it works, and then we will see. So there are few things for you to understand in linear regression before going into the depth of it. So I will also tell you a basic math, not a very high end math, but a basic mathematics that is required for this thing, right? So you can see you have a x and you have a y. X is your independent variable, y is your dependent variable, and then you have drawn a line that looks like that, whatever line you have. That is not a final line but a sum line. So you have to put some line. So when you put one line, wherever the line is there, if you want to measure what is the value of x and y at any given point in time, you can draw a horizontal line and a vertical line to find out the values of x and y for a given point in the line. Is this clear to all of you? So what I'm trying to tell you is you have x-axis, y-axis, and then you have a line, correct? So if you want to find what is the value of x and y here, how do you find? You will draw one line here and you will draw one line here. So this is the value of x here. This is the value of y here. Similarly, if you want the value of x and y here, what you will do? You will draw a line here, find the value of x. You will draw one more line here and find the value of y. Clear? So now we'll do one thing. You can see. So this is something that I'm just trying to tell you. These are the basic understanding of linear regression. So whenever you are going to do this, you can see a basic linear regression is nothing but they've just given you a positive line. So nothing much in this. So you have an independent variable, you have a dependent variable, you have a positive line, which means with increasing independent variable, dependent variable also increases. Clear? Now, having said this, let us go to the next one. So this is a negative one. So this you saw positive and this is a negative. So when your independent variable increasing, the y is decreasing, which means when the temperature is increasing, the number of sweaters will decrease. Correct? Agree? Temperature increases means it will become summer. So in summer, no one wears sweaters. So that is your negative relationship. So positive relationship, negative relationship, you understood. This is just a simple line. Now, whatever line you are seeing, that we can also call it as line of linear regression, because linear regression is a straight line. So some of you said y is equal to mx plus c. So y is equal to mx plus c is the equation of a straight line. So whatever line you are seeing here, we can call it also as a line of regression, line of linear regression. So this is something that we can use. Fine. Now you have data points. So data points are called as observations. Good, clear. So you understood what is. I will before going to the next steps, we will recap and then we will see what are all this. Now, before going into the next slide, I will tell you few slides. Just check this. So what we saw is independent variable, dependent variable, and a line. So if you want to find any point in the line, you either draw a horizontal axis or a vertical line and then find the value of x and y. So this is line. Then you have a positive relationship line, negative relationship line. This line is also called as a line of linear regression. And then any dots that are there in the graph are called observations. Is it clear to all of you till here? So this is your observation. So these are some of the basic things that you should understand whenever we are going to do a linear regression. So these are just data points, two observations I put, just normal data point, nothing much. So we call them as observations. Now, whenever you go to a linear regression, you have something called as the least square method. So what do you mean by a least square method is you're going to reduce your errors. How are we going to do that? We will check it. And now for our understanding, x is an independent variable, y is a dependent variable, and then I have multiple dots here, which are the dots that I will be using for my observations. So they are my observations. And then the linear regression line is the least square method, whatever we have used by reducing errors. That is the line that represents the relationship between x and y. How we are going to do it, all of that we will see. So basically, this line, all the points will be around this line. So this gives us a fair, good estimation about the data points. Is this clear? How we are going to get it, we will see. But this is how it looks. Clear? Now, what we are going to do is observe this carefully. From this line, I'm considering 2 points. One is this point and one is this point. Now, according to your linear regression line, yeah, it will not be a straight line. So it will not be a straight line. So that is why we are not connecting the dots. So according to linear regression, if my x is this, my y should be here, correct? But my y is here. If my x is this, y should be here, but y is here, because it is giving you an estimate. It is not exactly telling you. Similarly, consider this point and this point. If my x is this, according to the linear regression line, the value of y should be this. Same here. If my x was here, the value of y should be here, not here. So you're getting these things, what I told you just now? Nice. So now, if you have these things like this, what happens is you can see whenever you have a estimated value, there will be a difference between your estimated value on the linear regression line and also the actual value that you are seeing in the linear regression line. So there will be a slight difference between your estimated value and also the actual value in the linear regression line. So this thing is what we call it as the error. You are estimating something in the linear regression line, but in reality the data point is somewhere else. So this is what we call as the error term. Is it fine to all of you? Understood? Here there are no outliers. So what is your estimated value and what is your error term? So this is very simple, I'm telling you. Very simple terms. I'm not using any complex words here, right? So you're having a linear regression line for estimating your data points. But what happens is, this is the one that I'm keeping my mouse pointer. This is a good estimate where the estimate lies on the line. But all others are either a little up or little down, which means there is a small error between every data point and the line. So this is your estimated value, this is your actual value, and this is the error term. Correct? Understood? So whatever is your estimated value, the difference between your estimated value and actual value is the error term. Clear? So these light blue dots are the estimates actually. I mean, not the estimates, but the observations. The blue dots are observations. This line is the estimate line. All of you are clear about these things, what we discussed, right? Now, let me go to the next. So similarly, just like how we have error for these two, you can have errors for all data points, correct? Agree? So just like how you have a estimate, you're finding the difference between your estimated value and the actual value. So you have an error term. Similarly, you can find error for all the observations from your estimated line, correct? So this is one estimated line that you have given. Similar to this estimated line, you can draw few more lines like this, like this, like this. There is no standard rule, right? So this is the estimated line. There's no standard rule. This is one of the estimated line. So with every estimated line, you can find out the error terms for every observation, correct? Python, don't worry, Python we will look at it tomorrow. Now we are talking about linear regression. Krishnan, by any chance, did you join late? Okay, that's the reason. So I've explained all of that in the beginning. No issues. So please try to be on time so that it will be helpful, right? So these are observations, whatever we have. Our objective is to find out an estimator line which is a very fair estimator of all these observations. So I can draw multiple lines. I can draw 100 lines here, 1000 lines here, but my objective is to find out the line that will best fit all these data points. So whatever one line that I have drawn, with that I can get some error terms. So let us say I will draw one more line like this. For that line also I will get some error terms. So let us say I'll draw one more line like this. For that also I'll get some error terms, correct? So now the only thing that I am telling you is for every estimated line, you will get errors from all the data points, correct? All of you agree? This is one estimator line. You have found out errors for all the terms. Now, if I have multiple estimator lines, I can have errors for all of them, correct? Every estimator line will get an error. There is no estimator line that will give you zero error, correct? All of you agree with me? Because it's a straight line. Now, just one line I will tell you, and that is your linear regression. Out of that 100 estimator lines, which are giving different types of errors, the linear regression line is one which will give you the least error. Got it? That is as simple as that. So our objective is to find out a straight line, correct? Linear means it is a straight line. True. Least error for all values, correct? So I have my independent variable and dependent variable. Based on the value of independent variable and dependent variable, I have multiple observations. Now, my duty is to find out a straight line relationship for all these dots because we are doing linear regression. Linear regression means straight line. So, how am I going to find out that straight line relationship? By drawing multiple lines. So I don't know which is the correct line. So I will draw 100 lines and I will find out the error for every line. What is my estimated value? What is the actual value? What is my estimated value? What is the actual value? Like that, I will find the error for all the 100 lines. The best line that will fit is that line which gives me least error. That's all. Clear? Agree? Clear to all of you? So now, if this concept is clear, the further Gurvinder, no means it is not clear or no questions. Okay. Now, so this is how you are able to get the best estimate line. So how are we going to do that? I will show you. You can see now you have speed and also the distance. So both of them are having a positive relationship, right? So this is having a positive relationship. So if you go with more speed, you will go longer distance. So that is the general thing all of us know. So if I go faster, I'll be able to cover more distance. So that is one thing. Now, let us say I will travel at 1 kilometer per hour. Okay. My speed is 1 kilometer per hour. I will go how much distance in, let's say, 1 hour, 1 kilometer. If I travel at 5 kilometers per hour speed, I will travel 5 kilometers. If I travel at 100 kilometers per hour, you will go 100 kilometers. So basically, this is a straight line linear relationship. The more speed that you go, the more distance that you travel. There is no issue in this. Correct? Now, what happens is whenever you have this x and y, the distance traveled in a duration of time is your y. Understand this variables. The distance is your dependent variable because distance depends on speed. Speed is not dependent on distance, right? So the distance depends on speed and speed is not dependent on distance. Now, having said this, the straight line relationship, all of you know it is y is equal to mx plus c. But what is y, what is x, what is c, and all of that we will see. There are two terms here which you already know. One is y and one is your x. X is speed, y is distance. Clear till here to everyone? What is m, what is c, we will see. Now, let us say, for example, x is the speed of vehicle, y is distance, x is speed. So you saw that. Now, m is nothing but the slope. So what do you mean by slope? Slope means delta y by delta x. So that is the formula, which means you take a small piece, delta y by delta x is the formula. But for us, as of now, let us understand whether it is a positive or negative, right? Positive or negative. As of now, the slope is positive, which means there's a positive relationship. So that one we will keep in mind. Next, no. The slope, how you calculate is you take a small piece of x here, you take a small piece of y here, you take a small piece of x here correspondingly. It comes like a triangle. So this difference of y and this difference of x is the slope, which we are not using here. Correct? Dy by dx. So which is not required right now. I will tell you. See, assuming that all of us are new, I'm just telling you right now. Right? Right. So we'll just go ahead and then see how it works. Now you understood what is y, what is x. M is the slope. Positive means it is going upwards. Correct. So now M is a positive slope. What is C? So C is nothing but the value of y when your x is 0. C is the value of y when your x is 0, which we call it as an intercept, which means when my x becomes 0, what is the value of y? So you would have seen, right? So whenever there is, let us say, for example, I'll give you one example of marketing budget and the sales. So if marketing budget is your x, and then yeah, c is a constant variable, correct? So it's a constant one. So marketing budget is x and sales is y. Assume that in one particular year, the company doesn't give any marketing budget. They keep their marketing budget as 0. Do you think there will be no sales at all if marketing budget is 0? Do you think there will be no sales at all? There will be some sales, no? I'll tell you, I'll give you some good examples so we can all connect, right? Based on previous marketing spend is one thing, but even though if it's not based on previous marketing spend also, there will be some sales. Let us say, for example, there will be, okay, fine. I'll ask you one question. How many of you are seeing petrol advertisements these days? Anyone seeing petrol advertisements?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
Indian Oil, HP, Bharat Petroleum. Do you think there are no sales? Every day everyone will buy petrol, no? That is a necessity, correct? Forget about that. How many of you remember seeing ad of a notebook or a pen or a pencil in the last 3 months? They used to come, correct? Have you seen any advertisement of a pen or a pencil in the last 3 months? No, right? Okay, I'll give you one very good example of marketing. Have you seen ad of Lux soap in the last 3 months? Where did it go? Yeah, everyone used to come. No, no, none of you would have seen. But soap sales are there. No, you go and ask in the shop, he will give you Lux soap. No, after COVID coming, only Lifebuoy and Dettol ads are coming. Correct? Lifebuoy, Dettol, Lysol, Savlon. Four ads are coming very much. Anyway, so this is an example of C. Why I'm telling you this is remember this properly, right? Yeah. So C is correct. Lux, Lifebuoy, Lysol. So just remember this, and you can see even though there is no marketing that is happening, there will be some sales. So that is your C, which is your y-intercept. With zero marketing budget, you will be getting at least some sales. So that is your intercept. Now here that thing doesn't work because if you are traveling at 0 kilometers per hour, you will be at zero only. So the speed and distance thing doesn't come. So I just took an example of marketing budget. So this is a simple example. Y is equal to mx plus c. So now all the items in y is equal to mx plus c. Are you comfortable? Did you understand? This thing also I will upload it to your LMS. Just check, and then I will also upload all the codes and all of that so that you can use them. So don't worry, I will give you all the material. So if the line goes down, it's negative slope. Yeah. Sanjay, basically, if the speed increases, the distance traveled by you also increases. Here, it's a positive slope. M is positive. So y is distance, x is speed. C is nothing but when your x-axis is 0, what is the value of y-axis? So that is why we took example of a marketing, right? So this is something that we will go. Let us go to the next one. So this I already told you. C is equal to y intercept line. So C is equal to y when x is 0. So 0 into m is 0. So y will be equal to C. So this is, so negative slope is nothing but we can just say, yeah, ice cream versus temperature. No, not ice cream versus temperature, sweater versus temperature. So ice cream will increase. So sweater versus temperature. Number of sweaters versus temperature is negative slope. As temperature increases, the sweater sales will decrease. So that is negative. You can see this is negative. Y is equal to minus mx plus c. So which means as let us say you want to travel 100 kilometers, as your speed increases, the time required to travel will decrease. So if you go slowly, it will take long time. Correct. So this is basically the example of negative one. Correct. All of you are clear? So if you go slowly, it will take long time. If you go fast, it will take less time. So this is something which is for negative. Now, having said this, you can see all these things are y is equal to mx plus c, dependent variable, independent variable, all these things you already know. Now, we will understand the concept of finding the best fit line. So how are we going to get the best fit line? And also, how do we measure how good the line is or how good the linear regression line explains the relationship? That also we will see in this particular mathematical calculations. Now I have x, I have y. So x is 1 2 3 4 5, y is this one. Now what I'm going to do here is I'm just plotting for every value of x, I'm plotting a value of y. So for 1, I'm plotting 4. For 2, I'm plotting 3. For 3, I'm plotting 4. So similarly, whatever value is there here, I'm plotting all of them one after the other. So if I do that like this, for 1, I'll plot 4 for this value. For 2, I'll plot 3. So similarly, I'll get a plot like this for a given value of x and y. So this is my independent variable. This is my dependent variable. All of you know. So now I need to find out a line that will be a best fit line. Best fit line means that will give me a good estimate of whatever I'm trying to do. So that is something which I am supposed to find. So how am I going to find mean of your x and y? So if you find the mean of your x and y, you will get 3 for x bar. This is, I think, 3.6 for y bar. You can see this is 3.6 for y bar. 3 comma 3.6. Understood? First step, find the mean. I want you to tell me yes or no for every step, please. Understood? You plot x and y, find the mean of x, find the mean of y. So this is step number 1. And then you plot this thing here. Why am I taking that one? Is if you see that a good estimate line will pass through the mean, which means whatever line I draw, I cannot draw a line here like this, I can draw, but a best fit line somehow has to pass through this point, like this, like this, like this, like this. Somewhat it should go, but it should pass through this point. So that is the objective why we found out this mean. So x bar, y bar, we find a mean and then we plot it here. So this is step number 1. Step number 2 is I have just put the estimate. So y is equal to mx plus c. I have taken a rough estimate line. So this is not the final one. I've just taken one line like this. I can take like this also. I can take like this also. I can take however I want. But that line should pass through this dot. Clear to all of you till here? Nice. Now we will see what is this point. So this point, all of you know, this is nothing but 3 comma 3 comma 3.6. So that's what I took. The straight line drawn connect to the mean of x and y to x and y axis. Correct. So the straight line is drawn connecting to the mean of x and y axis. Correct. You're right. True. What you said is true. The straight line is drawn by connecting the mean of your x and y. So that is step number 1. My next step is finding the value of m. So how am I going to find the value of m? The value of m is nothing but for every value of x, okay, just see the formula. It is summation x minus x bar into y minus y bar divided by x minus x bar the whole square. So it's a summation. So what you are supposed to do, you are supposed to find x minus x bar, y minus y bar. So to find the value of m. So you know what is y, you know what is x. So only two things that you need is what is m and what is c. So c you will get if you make your x is equal to 0. X bar is the mean. X bar means mean, right? So x bar is mean. So we have found it out. I'll show you. You can see here. You found a mean x bar, mean y bar. So x bar, y bar is mean. Now you have x, you have y. You will get the value of c if you make x is equal to 0. The only thing that you are missing here is m. So m is your slope. So the value of m can be found by x minus x bar into y minus y bar divided by x minus x bar the whole square. Now what I'm going to do is, I know the x bar value, y bar value. I will find x minus x bar, y minus y bar in two new columns. So 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. So that is my x minus x bar. 3.6 minus 4, 3.6 minus 3, 3.6 minus 4, sorry, the other way around. 4 minus 3.6, 3 minus 3.6 like this. I just did x bar, but it's the other way around. 1 minus 3, 2 minus 3, 3 minus 3 like that. 4 minus 3.6, 3 minus 3.6 like that. So if you find x bar and y bar in two new columns, it will look like this, correct? Don't worry about the graph, but I'll show you the numbers. Just see the numbers. X minus x bar means the difference between your x-axis error. So similarly, when you do for all of them, it says this is far away this much from this x bar. Mean. Y means This is so much distance away from my mean. Clear? Till here, is it clear to all of you? X minus x bar, y minus y bar, x minus x bar whole square. Clear? You're just finding these 2 points. Now, what you will do is you will find the value of m by dividing. First, what you're supposed to do, you're supposed to sum up x minus x bar and y minus y bar, and then sum up this. You're supposed to multiply these two, sum them up, and divide by this. So if you do that, you can see you will get one value. X minus x bar, y minus y bar is like this. You will get all these values. Summation of x minus x bar, y minus y bar is 1. Summation of x minus x bar whole square is 10. So basically 1 by 10. So 1 by 10 is what? 0.1. So that is the value of your m. Correct? Got it? No issues still here. Now you can replace y is equal to 0.1x plus c. That is your linear regression equation. Clear? See 3.6. See, y is 3.6 here because y average is 3.6. M is 0.1. You got it. No, c also will get it. And then x is 3 average. Now 3.6 is equal to 0.3 plus c. You're getting how you're getting this equation. Now tell me what is value of c? 3.3. Now you got it. Now once you get your c value, now tell me what is your linear regression equation? Y is equal to mx plus c with what all values you found out. What is the linear regression equation? Y is equal to 0.1 x plus c value. We got it na just now. Exactly. Y is equal to 0.1 x plus 3.3. So that is my linear regression equation. You can see that is what you will get. C is 3.3. Now plot the C here. Any line, I mean, see, all of you know, to draw a straight line, minimum how many points are needed? 2 points. To draw a straight line, minimum 2 points are needed. So 1 point you got it by using the mean of x and y. 1 more point you got it by C. So now you can draw the straight line. You have 2 points, no? One you got it by using x bar and y bar. 1 more point you got it using C. With these 2 points, don't you think you can draw a straight line? All of you got it? Now, this is the line that you will be considering for your linear regression. Very simple. Step by step, I will tell you, and then we will see. You can see equation is same what you said, regression equation, y is equal to plus 3.3. Now, by this you can estimate. I'll just repeat the complete process once again. This is the line of best fit, correct? This is the best fit line. I'll tell you the step-by-step approach once again. Just see if you're able to understand or not. So I'll just run it once fastly so that you can just observe and then tell me. So this is a quick round. Okay. Understand this carefully. To find out a linear regression equation, what are we going to do? We have independent variables and dependent variables. We plot them like this, all of them. First step, find out x bar y bar, which is mean of x and mean of y, and then plot a dot using these two values. You got 1 point. To draw a line, you need another point to draw a line. So what is the equation of your straight line? Y is equal to mx plus c. C is your y-intercept, y is dependent variable, x is independent variable, m is a slope. Now what we are going to do is, by using these values, we are going to, you plotted a dot. Then to find out my value of m is nothing but x minus x, summation of x minus x bar into y minus y bar, x minus x bar whole square summation. So this is the formula. So anyway, you have x, you have x bar, you have y, you have y bar. So you find out m. So you basically find x minus x bar, and then y minus y bar, and then x minus x bar whole square. Then do a summation of these two. Then you will get 0.1 as your m. Now you have your value of m. So y you know, x you know, m you know, c you need to find out. So what you will do, you will replace them. For x you will put it as 3, for y you will put it as 3.6, for m you will put it as 0.1. So if you replace these values, then what you will get is c is equal to 3.3. So you already got 3. Now a generic value which means C is nothing but y-intercept, which is 3.3, which means you'll put a point here. This point is 3.3. Now you have 2 points, you draw a best fit line. So now this is the particular linear regression line that you're having. Now if you want to construct a linear regression equation, y is equal to m is what? M is 0.1, C is what? 3.3. Y is equal to 0.1x plus 3.3. So that is your linear regression equation. Step by step approach. Clear? We are not going to run all these things in code, Sanjay. So what we are going to do is we are just going to see few things. I mean, how to build a linear regression model. So these things you're not running in code. These things will be used to learn. So in Python, it is only 1 or 2 lines of code to draw a machine learning model. But you should know how it works, no? So that is the reason. Now you understood this particular equation, which will give you a fairly good estimate of the data, which means it will tell you like, okay, how your data is there. Just like how we have accuracy and other things, right? So we also should have a metrics which will tell us how good or how well this particular line is explaining my data, right? So it is not 100% good model. I mean 100% best fit line, because you have some error here, some error here, some error here and here. This is the line that will give you the least error, correct? There are multiple ways of finding that least error. One is called as ordinal least square, one is called as gradient descent. So multiple types are there. This is one of the type. Now, having said this, so you can see your m value is 0.1, c value is 3.3, y is equal to 0.1x plus 3.3. Now what you will do is, for a given value of m, understand this carefully, for given m is equal to 0.1, c is equal to 3.3, let us predict values for y when x is equal to 1, 2, 3, 4, 5. Here, if you can see, the value of x is 1, 2, 3, 4, 5. So these are actual values. Y is equal to 4, 3, 4, 2, 5. These are actual values. You have got the line. Now you will predict the values. So if you predict the values, it will become 3.2, 3.1, something, you will get. So predicted values. So blue is your actual value. Red is your predicted value. Clear? By using the linear regression equation. Clear to all of you? Now, once you do this particular prediction, just replace your value of x with 1, 2, 3, 4, 5, and then you will get the value of y. So this is your predicted values. So you have actual values and predicted values. Now, the next step is, this is, as I told you, finding the best fit line, gradient search, and then you have OLS, multiple methods. What we are trying to do is, you are just trying to see what is the goodness of fit of this particular line. So this is my x, this is my yp. Yp means y predicted. I have something called as r square. R square is a measure of goodness of fit. You can consider R square as an analogous to your accuracy, which means you can probably understand R square is similar to your accuracy, which means how well my model is able to explain my objectives or observations. B are actual, red is estimated. Blue are actual, red is estimated values on the line. Estimated values, all of them are there on the line. How do I find R square? R square is an error term. Okay. R square is nothing but predicted distance minus mean divided by actual distance minus mean, the whole square. Predicted distance minus mean. What is my y bar? All of you know y bar is 3.6. You saw on the top, correct? Y bar was 3.6. You can see y bar is 3.6. Now, predicted minus mean, actual minus mean. So yp, y bar, y bar. So if you sum them and then keep it, you can see you can do this. Yp minus y bar, y minus y bar. So summation, and then this also you have. So when you sum this, you will get 1.9 and 5.2. right? So 1.9 by 5.2, this is your R square. So you get 0.36. R square is 0.36. R square is 0.36. You can see this. There are some different lines I am trying to show you. R square for our particular line is 0.36, which means my model is around 36% it is explaining. It is not explaining me the complete observations. So it is not explaining complete observations. It is only explaining around 36%. So when I just say my line, I'm only around 36% confident that I'm able to get a correct estimate. So that is the goodness of fit or R square. Now, if I were to show you a few more lines, so let us say, for example, when R square is 0.6, which means your dots will be good. So this is for a different values. I'm just telling you example how it varies. 3.6, it looked like this. All the dots were far away. 0.6, all dots are little nearby. So if you bring them little more closer, your R square will increase. So basically, your R square will reduce if your data points are far away from the line. R square will increase if your data points are near to the line. So if your actual versus predicted both are same, then R square is 1. So this is something that I wanted to tell you, R square. Is this clear about R square? Goodness of it clear to all of you? So R2 is R2 is R square. It's not R2. It's R square. R square is a goodness of fit, which means how well my line is able to explain the observations, which means how nearly, let us say for example, how near the data points are near to my line. So it's a degree. So when I say 100, all data points are near to my line. I have a very good estimate, very linear, very good. If this increases, which means the data points are far away, which means only 60% correctly my line is able to explain the dots. Correct? So that is your R square. I'll explain R square again. Just see and then understand this. Okay. So all of you know how to find this particular linear regression equation. Correct? How frequently, but you don't call it as how frequently my actual and this will sync. It is nothing but how, to what extent you are able to explain your y and x. Are you able to explain it 100% or are you able to explain only 30% of the times? So that is R square. So now it's a goodness of fit of a linear regression line. Now let us say this line you found out. What you will do is, by using this linear regression line, you will find the estimated values. So you have a set of actual values for every value of 1, 2, 3, 4, 5. For every value of 1, 2, 3, 4, 5, you have a set of observations. Listen to me carefully and later we can have a Q&A session. Concept you understand it, then you will be able to understand all the questions also. For a given set of independent variables, 1, 2, 3, 4, 5, I have some observations which are plotted in blue. By using the linear regression line, I am predicting values for every independent variable which are plotted in red. So I have actual values in blue, predicted values in red. Y is blue, YP is red. Okay, Y is blue, YP is red. Right? So Y is blue, YP is red. So you are estimating Y is equal to all these values. So these are your actual values and these are your estimated values. Now our objective is to find something called as mean squared error. Mean squared error is something called as R square. So how are we find out that R square is by using these particular calculations, which I'm going to explain you now, right? R square is nothing but mean square error that will tell you the goodness of fit for a model. So R square will tell you a goodness of fit. Let us go ahead and then see step number 1. right? So this is your linear regression line. Y is equal to 0.1x plus 3.3. So this is the linear regression equation. By using this, we identified this actual values and the estimated values. Now, to see how exactly I'm going to find my mean square error, which will give me a goodness of fit, which is r square, I am going to find out the predicted values. You can see here the regression line, and also you are finding your r square. The formula of r square is nothing but predicted distance by mean divided by actual distance by mean. So predicted distance by mean and actual distance by mean. So mean you know how to find. So y bar 3.6. So predicted distance minus mean, which means yp minus mean. Actual distance minus mean means this value minus mean. So this things that we are supposed to do. You know y, you know yp. Yp you identified like this, right? So all these values that you're getting are y predicted. 3.2, 3.1. So calculation mistake is there, but this is the values of yp. So you're getting for every value of x, you're identifying yp. You also have y for every value of x. So you have y for every value of x, which is actual value. Yp is the predicted value using the linear regression line. So you have y and yp. Now to find out your r square, you know the formula yp minus y bar whole square by y minus y bar whole square. You sum them and take a ratio. So you find yp minus y bar. So you have y and yp. So you find yp minus y bar. Then you have y. So you find difference y minus y bar. So these thing you find. Take a summation of both. You will get 1.9 by 5.2. 1.9 by 5.2 is 0.36, which means your r square is 0.36. Around 36% your line is able to explain the dots, which means 36% of the line is able to explain the dots, and that is how your goodness of fit. Your line is good enough 36% of the times to identify the values, or you can indirectly say that your model is around 36% able to give a good estimate of your basic y when for every given value of x. So now how r square varies is when your r square increases, all your observed values will be equal to your estimated value. So you can see r square is 1 means it will be like this. R square varies between 0 and 1. R square is 0 means a very bad model. R square 1 also very bad model. R square 0 means a underfit model. R square 1 is a overfit model. Overfitting is also not good. Underfitting is also not good. A good estimate of R square is somewhere approximately 0.7, 0.6 to 0.85 or 0.9. So that is the good estimate of a good R square. So this is how you find out your R square. Is this concepts clear to all of you? Yeah, the idea behind giving negative, squaring is nothing but error can be positive or negative. So let us say you have 10 data points, 5 values have negative error, 5 values have positive error. If you just sum them, it will become 0. To avoid that, to get a very good estimate of error or to get the true value of error, you square them and you will take it. Overfitting, I have not told you. I'm just told you that term. I will explain it in detail. Don't worry. So, but as of now, it's not necessary. I just told you because since you asked me what is the range, so 0 means underfit, 101 means overfit, right? Fine. So all of you are able to understand this concept, how exactly this thing is working. Okay. Fair enough. So I request all of you to open your Jupyter notebooks. We will start building the regression now.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
and then step by step, like how we used to build, we'll try to build the linear regression. I'll explain what is the data set and we will see. We will use this data for our analysis today. Done? Very nice. Fine. So everyone, all of you are able to read this and see this. We'll go into the data now. So, okay, fine. So all of you are able to read it, no issues. So now, this is just for you to understand. I'm just giving you. So you have something called as a Boston data set, right? So this is nothing but data set contain information collected by US body about the house and everything. So it has like around 14 attributes. So you are seeing this here, 14 columns. So what are these columns? So basically, whenever you take a data, right, you will not understand all these details. Okay. So basically what it contains is like some of the information about the housing data, right? So your Jupiter location you can find here. So if you open here, this is your Jupiter location. So where your Jupiter is. So try to keep it in this folder. You can see mine is machine learning, linear regression, hands-on code, linear regression. So in this folder, you have to keep it. So wherever your current file is there, it's just this thing now browser. Just click that and then you'll be able to get it. Right. So it's in the browser, it will show in the top. Now, so I will go ahead and then I will tell you slowly, David, try in case if you're not getting, no worries. So you can follow this and later you can read it from the recordings, whatever we have showed how to read the document and all and practice. So don't worry. So we'll help you. No issues. Right. So, but please try right now. If you can read, it will be great. So now what I am trying to tell you is there are 14 variables. I will explain each one of them, right? So whenever you get a data, what happens is you may not know all the variables. So understanding the variables is very important, right? So you have something called as scrim, you have something called as zn, you have something called as index, you have something called as like indus, cas, nox, rm. So what are these? We need to understand so that we get a idea like what is the main thing that is driving what we want to find, right? So now the first one, crim, means per capita crime rate. So crim means per capita crime rate. So what is the crime rate? So obviously if crime rate is high, then the price of the house in that locality is less, correct? No one wants to be in a place where crime rate is high. Agree, all of you? So which means it's like a negative correlated variable. So you'll get a understanding that okay, one variable you understood. Now you have Zn. So Zn is nothing but proportion of the residential land zoned for lots over 25,000 square feet approximately. That is the zone, which means in that zone, what is the land for lots? So which means government is doing some kind of activity there. So that is also one variable that is there, Zn. So which means zoned, right? For some zone they are taking something, let's say for example for an IT park, or maybe for some bus station, or maybe for some college or something, government is zoned, right, for some purpose. That is Zn. How many, what is the area that is zoned? That is something. Now you have something called as indus. So indus is nothing but proportion of non-retail business acres per town, which means, let us say if you take a town, how many acres is non-retail business area, which means more the business area, better will be the price. So that is variable. Some people don't want to stay in business area, some people want to stay outside. So that is also depending. So what is it? So indus is some one variable. Now you have chas. So what is chas? Chas is nothing but there is a river which is called Charles River. So Charles River, one, if river is bound, which means if the river is passing near your house, if you have a good view. If it's zero, which means river is not passing by your house. So that is CHAS, chas. Then I have NOx. NOx is nothing but nitric oxide concentration, right? So parts per 10 million. Now tell me, nitric oxide concentration NOx, is it a positive one or a negative one? So when nitric oxide is more, your price of house will be more or it will be less. Price will be less. No one wants to stay in nitric oxide location, correct? Cool. So now RM. So RM is nothing but, yeah, river view depends on flooding. So there are so many things that are influencing, as you rightly said, correct. Now RM is nothing but average number of rooms per dwelling. So what is average number of rooms per dwelling? Which means let us say you have a location. In that, what are the average number of rooms that are there for every house? So that is RM. Then age is nothing but proportion of there are two things. Okay, age, if you can see, 65, 78, all these things are there. So what is the age of the building? So that is your age. So basically, more the age, lesser the price. This means weighted distance to the employment centers. So this means how far is it from a tech park? So to be simple, so that is your how far is it from tech park. And then RAD means accessibility to highways. How many highways are near to that location? 1, 2, 3, something like that, right? So that is, these are some things that you need to know. Now tax is nothing but the property tax. What is the value of property tax? That is in thousands. So that is something they have given. And later I have PT ratio. What is PT ratio? PT ratio is nothing but nearby my house, how many schools, what is the pupil and teacher ratio by town, right? So there are 505 towns, and you have what is the pupil and teacher ratio. So if someone wants to go to school, so that is something. And I have something called as a black, right? So black is nothing but the proportion of people from African origin. What is the percentage? So what is the number of people? So what is the what do you say, like proportion of the place owned by African origin people? So that is black. LStat percentage, which means what is the percentage of lower status people, so in the complete community. Last but not the least, you have MEDV. So MEDV is nothing but the value of the property in thousands. So the value of property in thousands. So this is the data. In this, if you want to predict the price, which is your dependent variable? Can someone tell me which is the dependent variable? I mean, what is your target, what you're trying to find? I told every variable, no? MEDV, which is the median value. Samir, all other than median are independent variables. MEDV is dependent variable. I think just a confusion you got, right? So dependent variable is dependent on all others. So price is dependent on all others. So that is something that you need to remember. So MEDV is something which we are going ahead and then finding our problem, right? Now we understood the data. So this is a preliminary step that you're supposed to do. Read and then just see the data. Then you will get a fairly good idea about how exactly you're going to deal with it, right? So this is something that we saw. Now, once we are completed with this, I just want you to basically understand the data. So data understanding creates a very good what do you say, if you understand the data well, then model creation will be easy. Without understanding the data, creating a model will be a little challenging, right? So you don't know what are all your variables, how they are functioning and all that, but this is how you get started. Now, once you understand all these variables, what are you going to do next? So the next step that we are going to do is we will see explore the data. So all of you know, right? So how are we going to explore the data? So basically we do all our describe, info and all of that, right? So you saw this, correct? So we will go ahead and then do the describe, info and all other things. So you can see I'm just checking the data type. So this is data frame. So shape will give me what? So basically 506 into 14. So rows and columns, correct? So just understanding how many rows, how many columns are there. I got it. So data dot head, all of you know. Now I'm just taking to data dot describe. So this describe will give you a basic statistical summary. So main thing, what you're supposed to look here in describe. One important thing you should look. What is it? First thing when you do a describe. No, before mean also no. So whenever you do a describe, your first thing, first check is the first line. See, all the columns are having 506. Exactly. So now what is the conclusion? I've run describe. So what is the conclusion? So which means no null values. There's no need for you to replace any null values. Correct? Exactly. So this is something that you need to understand right now. So this is the first step. Once you understand this data dot describe, what we are going to do is we will take two data points. So one is my LStat. So what is LStat? I told you, if you can recall. What is LStat? Exactly. So you remember them, right? The people with a lower financial status, correct? So people who are in a lower financial status, and MDev is nothing but the mean value of the price. So now if you can observe the LStat and MDev, is it a simple linear regression or multiple linear regression? So here, out of the 14 variables, I am selecting one independent and one dependent variable, correct? So I'm just taking one independent and one dependent variable. So which was like an example that we have, right? So whenever you have such single independent variable and single dependent variable, it is a simple linear regression. So this is something that we are supposed to do. So what we understood from data 37 is, right? So we are supposed to check this count. So if the count is same, which means we don't have any missing values. So that is the easiest way to find the missing values using describe. So that is the outcome that we are supposed to see, right? Just observe here. So the data has multiple columns, but we are just selecting two here to start with. So that is why I'm telling it is simple linear to start. You can see we are just taking two of them to start with. So let us see how it works. So that is the objective. We're not taking all of them. We're just taking one and checking it starting. So this is a simple linear regression. So you have it. Now, all of you know, right? So in the PPT also you had a similar data. So if you can observe, okay, you also you had the same kind of data. You can see you started with two variables like this, x and y, 1 2 3 4 5 and here, but the only difference here is instead of 5 variables you are having around 500 variables. That's all. Now first thing what we did, we supported to plot. Now I'll ask you one question here. This is all you know, so you're already done. Data dot plot x y style, all these things is there. Now what kind of plot will come? Bar graph, scatter plot, area graph, what will come? All of you have done it already in matplotlib. I think I only have taught you. Tell me what plot will come in this. Are you sure? I have not mentioned bar anyway. Na? For bar, we need to give bar or bar h. So line also I have not given. So line means, okay, fine. Okay, you may think it's line. Okay, fine. I agree. Okay. Few people think it's line, few people think it's scatter. Okay, fine. So why am I not telling line? Because you can see both of them are continuous. So if both the x and y are continuous, do you think you can plot a line graph? At least x should be discrete, no? For 1, what is the value of y? For 2, what is the value of y? So if you have like that, at least you can plot a line. But both of them are continuous. You don't know what point comes where. So do you think line graph is possible? Think and tell me, is it line or scatter? Again, scatter, correct. So once you run this, you can see you will get a scatter plot. All of you are able to understand this. It has a legend, it has LStat, it has MDev. So all these things. Cool. Are we fine? Okay. Yes. So you people are understanding. So what is the line, right? How it goes? Is it positive or negative? You take some time, try to type it. So we need to type the code as right. So slowly you type, no issues. I mean, if you're not typing also, typing is only for practice, right? So it is negative correlation, correct? Fine. So there is no reason. See, your x value is continuous. Y value is also continuous. So if you want a line graph, you should get for 5, it should be 30. For 10, it should be 40. For 15, it should be 20. So some kind of variable should be there so that you can connect them and make a line graph. You can also make a line graph here like this bar plot, but that doesn't look good. So that is why it is a scatter. Cool. So all of you are able to type till here and then get it. Anyone having any issues? So this graph is nothing but a comparison of the people who are having, it will run without subplot also. You're just plotting something. That's it. So data, plot, labels. I'm using 3 components. That's it. Right. So I have LStat and MDev. So what happens? The number of people, which means in a given location, more the number of people with lower financial stability or probably lower financial status, lesser will be the price. As the number of people with lower financial stability increases, the price will come down of the house. Understood? By default, it is correct. No issues. You can watch and then you can practice later. Anyway, this is something that we are going to. So basically, the comparison between two variables. You took two variables for an initial linear regression, correct? So you know what is LStat, the number of people with lower financial status, and you know what is the price of the house. So if the colony or if the location has more people whose financial status is less, the house price also will be less, correct? It is not a very posh area or a rich area. It's a low financial status area. So that is what we are seeing here. So you can see LStat, whenever you have the number of people with lesser financial status increasing, then the mean value of the house price also increases. Lesser the low financial status people, more will be the house, which price, which means it's a rich location. So if the number of people are more or locations are more, then the house price will drop. Is this clear to all of you? Cool. So till here it is. Now there are some assumptions in linear regression which I have not covered, but I'm just stating it to you. So those assumptions, correct. If the lower status people are high, then price is less. No, where price is high? LStat is less, which means less people. Then price is high. Here more people. Then price is less. People with low financial status will not take the house price higher. That will become a medium society. It's not a rich society for the price to become high, right? Now, don't you think you can get a linear relationship between LStat and MDev? Correct? So you can get a linear relationship. If 35 people are there, then you will get house at $10 million. If 5 people are there with less financial status, then your house is $50 million, which means you are in a rich location. If more low finance people, then you are in a moderate location, right? Thanks. So now you're going to plot a line or a whatever it is. So you are going to find a linear relationship between this, right? So this is a percentage, Krishna. So now what we are going to do here is we will just go ahead and then see how we are going to get a relationship between this, how our relationship comes, right? So if you can see this, there is a line that comes, right? So there's a line that comes. How to find that line, all of that we will see. Now, what is the next step once you do this? here you have x and y. So what is the next step? Can someone guess and tell me? Find mean. Okay. Before that, before finding mean and all that, what we are supposed to do? So like I will go step by step. Okay, we'll go step by step and then we will see. Right. So the first step is you need to identify what is your x and y. Correct. So out of these two, x is L stat, y is MDev, because price is dependent on L stat. So I'm just preparing my data accordingly. I'm taking x and y. I'm just checking. So try to do it till here. All of you are done. Just check, right? So some assumptions are there in linear regression. So which means the data should be linearly related. So if it is like scattered all around, then you can't do a linear regression. The first assumption is the dependent variables and independent variables should have a linear relationship, which means you should be able to fit a line. That is one assumption. So there are 2-3 assumptions more: multicollinearity, and also you have something called as constant error variance, which is called homoscedasticity and all, which not going to cover right now. It's not part of the course that is there, but I'm just telling you these things are also there. So you have some assumptions which needs to be taken care. But for initial version and initial learning, this is sufficient. So you can go to the next level and then you'll be able to understand them in detail. So that is something that I can probably tell you. So I'm just giving you a precursor. So I'm just giving you a precursor and then I'm just telling you about this, right? So this is something that I'm going to tell you. All right. So this is basically our dist plot. Now, having said this, what we are going to do is, this is O, not 0. Once you complete the visualization, we are preparing the data. You took what is X, Y, and then you did it. And don't worry about this ABCD. This one just I have just done an assignment just to explain. If you do any assignment like this, A will get 1, B will get 2, C will get 3, D will get 4. Correct? So this is how assignment happens. Order. Why I'm trying to tell you this is because whenever you do a sklearn.model selection, import train test split, here you give x train, x test, y train, y test. So this order should be maintained. If you miss this order, your variables would get jumbled. The output of train test split will come in this order only. First will be x train, then will be x test, then will be y train, then will be y test. So this is the order in which your output will come. So please ensure that this order is maintained. So to explain that, I have given you ABCD example. So I want you to just go ahead and then complete till here. So once you are done, just let me know and then we will see how it works. Right. So I just want to see it how we are going to do it. So split this and then we will see. Simple linear regression we will practice, and multiple linear regression also I will explain it to you. So it is similar to multiple, but usually what happens, you will always not have a simple linear regression. So you may have multiple linear regression also. So that is the reason I'll explain you multiple linear regression as well. We will work on. Cool. So all of you done till here? Done? Okay. Enough. Just see how exactly it works is, you can just see this. Okay, I have something called as train test split. So how this function works is, you're having your x value. So what is the x value? L stat. So you took your x value here. You have y value. So y value is nothing but mdev. So basically you have a x value and also a y value. So x and y is there. Now what you're trying to do is, you're splitting your x into x train and x test. You're splitting your y into y train and y test. So what is the proportion that you are splitting? So the first two arguments in train test split, the first two arguments is your x and y. So the order you need to follow: x train, x test, y train, y test. So this is the order you need to follow. Then train test split, the first one is x, second one is y, x and y. And later you need to define either a train size or a test size. So here I'm defining a test size. So what does test size mean? Test size, I am telling that the size of my test data set should be 20%, which means the train data is 80%. Random state 1 means whenever I give 1, generate the same kind of random variables. If I give 20, it will generate a different kind of random variables. It's like a key. Does that answer the question, Munaf? Understood? But this order you should be careful. X train, X test, Y train, Y test. Fine, Munaf? Getting the issues? Train means you're training the model, no? So you'll be training the model, right? Model you'll be training, na? That's why it is train. It is not the railway train. It's a training, model training train. Instead, I also in the beginning understood like why are they using train. So anyway, so 1, 2, 3 is like a key, right? So 1, 2, 3 is like a key. You can give any number you want. When I give 1, it will generate one set of random numbers. Understand? When I give 40, it will generate one more set of random numbers. It is like a key. Next time when you use 1, it will generate the same number of same set of random numbers which was generated in the beginning. So this is something like this. Assume that you have 10 containers. Every container's title is random state 1, random state 40, random state 62, something something is there. It is a key. Now in random state 1, you have set of random variables. Whenever you take random state 1, you will use that random variable set only. If you use random set 42, then you will have a different set of random variables, random numbers. So those things you will select. Is this understood? What happens otherwise? It will generate different set of random numbers every time without random state, right? So it will generate different set of random numbers every time if you don't give random state. Just to have a consistency in the random numbers, you will use random state is equal to 1, 2, 3 or something. Got it? Clear? Cool. Test size is nothing but you need to split your train and test data, no? So you need to split your train and test data. Train size is the percentage of your train data out of the 506 that you're having. Test size is the percentage of the test data out of that 500 that you're having. If you change random state, then the random variables will change as per the random state. But if you come back to 1, it will generate the same random variables that were generated when you used 1. That's it. Cool. Are we okay? Understood all of you? Why we have 4 variables here? X train, X test, Y train, Y test. So training means you need to train your data, right? So first thing you have to train. So for that you have 2 variables. For testing also you have to test. For that also you will have 2 variables. So basically training and testing both are there because you have to train your model and then test the model. So that's why. So X train, Y train will be used to train the model. X test, Y test will be used to test and validate the model. So that is why you have multiple things here. So what we'll do is next, there is one small thing that I want you to do, right? Yes, it should be both same for X and Y, correct? So now to build the model, so whatever you are seeing, this is the 3 lines that you will read. Nothing else apart from these 3 lines. Yes, Samir, you're right. 404 and 194. So you can see here, next one more library I am using it, which is nothing but my sklearn. So sklearn is a scikit-learn library, so that I'm using from here. So by using sklearn library, what we are trying to do is we are importing something called as a linear regression, right? From sklearn linear model, import linear regression. So scikit-learn has multiple models. So one is a linear regression that we are taking. So nothing else apart from that. So basically you are importing this linear regression function, storing it into a regressor, then you are fitting it. So this is the 3 lines that will help you build the models, right? First thing, importing linear regression, storing it into a variable, and then fitting it for X train and Y train. So when you fit it for X train and Y train, what happens is it will basically construct a model and train, it will construct a linear model and train it on X train and Y train. So just like how we did the complete math process, you remember yesterday we tried to solve y, m, x, c, we tried to find r square, we tried to find all of that. So this is something that it will do whenever you try to fit the model. Intercept means c, coefficient means m, correct? Clear? So these are the 3 lines that will come and then that will save.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So these are the 3 lines for building the model. It will take sometimes, if it is complex, it will take some time. If it is simple, it will run very quickly. Now, you all know what is intercept and what is coefficient, right? You can see when you put an intercept, you're getting 34. When you put a coefficient, you're getting 0.92, right? So you are getting a minus 0.92. What does this minus mean? Can someone answer? Correct, exactly, right? So you can see whenever you have minus 0.92, which means I have a negative relation. So obviously, right? So you can see by visualization also, all of you saw it is going to be a negative line. Your coefficient and these things are also telling that it's a negative one. So is this justified? Now, can someone type what is the linear regression equation? Y is equal to, can someone type the final regression equation, a mathematical relationship between your LSTAT and your MDev? So MDev is Y. MDev is equal to what? MDev is equal to, use MDev and LSTAT. LSTAT is equal to minus 0.29 MDev plus 34.33. Cool. Now, I have one question for all of you. What is the minimum value or the minimum price of a house if I have zero LSTAT people? What is the minimum value of a house if I have zero LSTAT people? Understood now the concept? Now you are able to understand how linear regression works. To get starting, hands on, you're doing it all by yourself. Whatever concepts you learn, you're using them and then you're doing. Okay. Yeah, is negative means LSTAT goes up, price will come. Correct. Tell me what is the question. Correct. We have two test and two train variables. Why we have it? Because X train and Y train. Now you know why I have X train and Y train to train the model. Correct. I have X test and Y test. To test my model, I will use X test. I will get a prediction. To compare my prediction with actual, I have Y test. MDev is Y. LSTAT is X. So all of you are able to understand it till here. No issues, no problem. Yeah, train test split is assigning 4 values. Yes, in this order. Train test, whatever you give. So you can see here X will be split into 2 pieces, X train and X test. Test size will be 20, train size will be 80. Y will be split into Y train and Y test. Test size will be 20, train size will be 80. It will not take decimals, it will take only integers. Just remove decimal, it will be 404. Correct. X train and X test, we can't correlate. So X train, X and Y are the variables that you need to understand. X train and X test, Y train and Y test are the variables. It's not the variables, they are the data small subsets that you're using to find out the model. So 404 is 80% of 506, 102 is 20% of 506. So that is the test size. If you give test size 0.2, then train size is 0.8. So 80% of 506 is 404, 20% is 102. Train and test both are different. X and Y are different. So X and Y is what you saw here. Now X and Y you used and we built a model statistically. But for machine to learn, I need to teach it. No, so teach it. I'm using X train and Y train. So to train the model. So this is the model you learn. Then based on this learning, whatever it has done on X train and Y train, it will test for X test and Y test. Clear, all of you? So now what I'm going to do is all of you got the equation. So this is how you build a linear regression, simple linear regression. So now you do a predictor. So ypred is equal to regressor dot predict. So what is there in my regressor? Regressor is linear regression. So y predict is equal to regressor dot predict of X test td dot data frame y pred columns is equal to columns. So you're just trying to type this and then predict it. Apart from that, now once I do my prediction, I'm just comparing my y pred with y test. So y pred and then y test, y pred and y test, if I do a comparison, which is my actual and which is my predicted? Can someone tell me? Test is actual because Test is what the data has in reality, correct? Y-pred is the predicted. So this is the things that we have, right? So this is the something. We can't take the entire data set, because if you take the entire data set, you will not have a data set for you to test it. If you take entire data and train, data will be over for training only. Exactly, you're getting the point. So now you have predicted and actual value. By comparing these two, you will get your R square. So we have to train and test every time we build a model? No. So first time you build it, there is a process of deploying models. So if you're using it, then no need to use the basic things that we are trying to do, whatever we are trying. But right now, yes, for building, training, testing, you have to do it. No other option. Now you have your predicted and actual. So now you are able to get your R square. So now there is no need for you to write the formula also. There are metrics available. I've printed all of them. So you can just take it later and then print it. I'm just showing it to you how it is done. Mean absolute error is MAE, you get. Mean squared error is metric, RMSE, R square. So these three things are some kinds of errors. Don't worry about this right now. Our focus is on R square. So you can see you have 52, which means what? Can someone tell me? SciPy and scikit-learn both are different. No comparison. Goodness of the model, it's not like 52% accurate, but it is able to explain around 52% of the variance that is there in the model. So that is what R square means. You can say it as an analogous to accuracy, but it is not accuracy. But you have an idea, right? So 52 means a moderately, like, not so good. So that is something that you need to understand. Fine. Now I'm just showing you briefly about multiple regression, which is not there in the coverage, but keeping learning interest in mind, I'm just showing it to you. So using one variable, you can't do regression, right? So you can't do a LSTAT and MDev. Only one variable will not influence. Now we have multiple variables. You can see the process is same. You have multiple linear regression. You import pandas, read the data set. Don't type this, no worries, just understand this, but understand the concept of multiple linear regression. But before going to that, I just want to confirm, simple linear regression is okay, right? You typed, you understood the flow, you understood the concept, how from data to get a model, coefficient, intercept, and also the R square. Nice. So this is a getting starting point for you. So on top of it, you have to explore. You can't get correlation using describe, right? So now we'll go to multiple linear regression, how it works. So basically you read the same data set, no change. Here what we are trying to do is, you can see ilog -1, which you are all aware. So what I'm trying to do here, x, I am assigning all the values except the last column, which means mdev. All of you agree, all these things are my x, only this is my y. So I'm assigning all these things to one variable, which is called as x, and I'm assigning only mdev to one variable, which is called as y. So basically I've split my x and y, right? So once I split my x and y, I'm just splitting the data, x train, x test, y train, y test, and all these things. So this is also done, split. There's no nothing great here. I'm just telling you. One thing that you need to note here is, you can see here you had one column x and one column y. Simple linear regression. Here you have 13 comma 1, which means x is 13, which means multiple variables are there, multiple linear. That's it. So only this is the change that you have to do whenever you're assigning your x and y. Rest all is the same. I'm just fitting a line. Here you can't visualize because two variables, 2D, 14, 13 variables, multiple dimension. You can't visualize it. Y is only one value because y is mdev. The target variable is 1. So that's why you have only one value. There are 13 x values and one y value. So that's why it is multiple linear regression. Now, the same thing that you are trying to do. Okay, let me just wait. Till here, is it clear to all of you? No issues? If things are clear till here, okay. ILOC, what we are doing, the last column, except last column, all other columns we are putting it into X. So here, All other columns are putting it into X. Only the last column we are putting it into Y. So that is what this ILOC is doing. Now you don't code it right now. So this is I'm explaining. So this you understand, then you can code it later, no problem, right? So you have these things. Now what we are trying to do is from sklearn import linear regression, and then you build a model. Once you build this model, next thing is finding out the coefficients and the C. Now tell me how many values of C will come and how many values of X will come. C will be 1, correct. X value will be 13, correct, exactly. So basically for every independent variable, you will have a coefficient. So that is what you will get here. You can see here, this is my coefficients. This is my attribute, which means when you combine both of them, you will get something like this. This is the equation. Now, if you want to make a multiple linear regression equation, how? Because you have 13 independent variables. So for every independent variable, you will get a coefficient. Now, for us to get a equation right now, so I did not get the value of C. So let me just put the value of C also. This is a predicted Y test. Let me just get the value of C as well. Coefficient is printed, intercept, right? Is it intercept? Let me just take the code. You can see 37, right? So now with these values, don't you think you can find the multiple regression equation? No, C will change. C will change if you change the variables, correct? I mean, see, C will change not for every value of X, but for every set of X. If you take 1X and 1Y, it will be different. If you take 3X's and 1Y, it will be different. If you take 4X and 1Y, it will be different. If you take 9X's and 1Y, it will be different because you're changing the variables every time. So that is the 13 different C, no, 13 different X, 13 different M you will get. Sorry, 13 different values of M you will get, not the C values. So now the regression equation is nothing but MDev is equal to minus 0.13 CRM plus 0.04 ZN plus 0.01 Indus plus 2.7 CHAS. So like that, like that, like that. Last plus what is the value of C? Around 37. That is my multiple regression equation. Clear to all of you? Any questions? We can't display the equation. We have to write it. There's no library. So separately, they will have different M and C, together different one. Yes, separately they'll have different, together different. Correct. Understood this concept of multiple linear regression, all of you? And this is nothing but our normal one. Our Y-pred is computed using both coefficients now. It is actually doing the same. Now, if you can see, if you include multiple variables, your R square has increased to 73. All of you saw that? Fine. All of you getting this point? How exactly we are seeing it? Is this concept clear to all of you? More number of variables, you will get good accuracy, but there is something called as dimensionality reduction. You remember I taught you dimensionality reduction? It's not more number, it is quality of variable. Yes, Jerry, you can go ahead and answer your questions. You got it? Okay, fine, no issues. So whatever negative numbers you are seeing here, which means when these things increase, your house price will decrease. When positive number increase, let's say Charles River. So who doesn't want a river view behind their house? So there its price is increasing. So who doesn't want something called as like RM? I forgot what was RM. So I think it was, I don't know, I'm not able to recall, but let me just see. And then you also have, let us say, for example, rooms per dwelling, correct? So rooms per dwelling is RM. So something like that, right? So you can just go ahead and then see this. And then based on this, you'll be able to do an analysis. You got it? Okay, fine, no issues. Let us start with something called as logistic regression today. So what do you mean by logistic regression? So there are two things here. One is logistic and another is a regression. So what do you understand by logistic? So anything related to logic or any idea? What do you mean by logistic regression? Anyone have heard about it before? Okay. So basically regression techniques can be used in multiple places. So you can use it for doing regression problems. So regression as in finding a straight line relation. You can also use it for doing a classification problem. So in this case, classification is nothing but you're classifying things into yes or no, one or two, pass or fail type. Understanding it, right? So basically, logistic regression is nothing but you are using our algorithm to do some kind of a classification. Logistic regression is a classification algorithm. Yes, it is basically for binary results. As of now, it is for binary results. We are doing a classification. Now, once you understand how exactly you do the classification, you will see an example of how it is done. Was for regression. So regression here means you're trying to get a straight line relationship. So that is regression. Now we are doing something called as classification, right? So classification is nothing but you're trying to classify things into multiple pieces, right? So yes or no, pass or fail types. So that is your classification. Now, having said all that, we'll go and then we will see how it works. So you can see what we are trying to do is we will see how we did linear regression, and then we will do introduction to logistic regression. What is logistic regression? Why do I need logistic regression? I have a spam email classifier and a summary. So looking back at linear regression, what all do you think that are there in linear regression? I will tell you. So you can see this is just a conversation that is going on, right? So if you can see here, what are the things that you saw in linear regression? You saw house price. So one guy is asking, help me find a property with bigger garden area for these many rupees. So other guy is saying, sure, I will help you. So what are the things that we can do? So X and Y. So you can see here, X is the amount where we'll get a property of area Y. So one guy is defining his X and Y parameters. Now, how do you find it out? So what is the area that we get? That is by simple linear regression. So we can see how. So you can see here, this is an example that we saw. Independent variable is revenue. Dependent variable is property size here, which means more money you give, bigger property you get. So basically, this is something, right? Garden independent variable is garden area, right? And then house area. So if your garden area is increasing, house area means it will become small, because if the plot size is limited, if garden area is increasing, house area will become small. So these are some of the examples of linear regression. Now, by using these things, what these people are trying to do is they're trying to find a house for their budget. So if Lawrence spends X amount of money, he can buy a property of so and so area. So he can tell that one because he knows the linear regression curve. Now, what is not assured here is, will the neighbors be good or not? That you don't know, right? Will the location be noiseless or not? That also you don't know. Those things you can't say, because you have to go to the property, check all that, and then only then you will understand it. So this is point number one. Point number two is, now you can see here you have multiple things or multiple aspects that you're considering. Will the property have good neighborhood or not? That is a yes or no kind of a problem. Will the location be noiseless or noisy? That is also a yes or no problem. So basically, if you can observe, this is like a classification. So as I told you, will it be noiseless or not? Will it be good neighbors or not? So those classifications. And along with that, you also have one more example that we are sharing here. Whenever you get an email can be a spam email or not, correct? It can be a spam email or not. So this is something that we are doing, right? Now, you can see here, there are some problems that a linear regression cannot answer. So those things, logistic regression will answer. So this is the main objective, correct? Whatever linear regression cannot answer, logistic regression will answer it. So this is something that I wanted to tell you. Now, you can see here, machine learning is basically classified into supervised, unsupervised. Supervised, you know, is regression and classification. Regression, you have linear regression. Classification, you have logistic regression and SVM. So today we are learning about logistic regression, right? Any confusion still here? Whatever I told you, there are some things which linear regression cannot solve. For that, we are using logistic regression. Clear? No issues? Fair enough. So now, what we will do is we will go to one step ahead and then see how it is done, right? So if you can see, statistically speaking, so whatever that you're trying to do here, if you can observe, whenever you try to do a classification model, so to start with, you will be using two things, which means binomial, like a yes or no, just to keep the things a little simple. Having said that, it is not only binomial, you can use multiple also, correct? So you can use multiple also, not just limited to binomial. So you can use multiple as well, but that we are not covering here since that is a complex one right now. We will be using it later. Having said that, we will just go ahead and then see how a binomial thing can be done, right? So we can just go ahead and we will be able to see how it works. So basically, binomial things is what something that we are trying to do. So whenever I say a binomial, or whenever I say it is like two outputs, you will be able to understand or probably get to see two places where you get the output. If you can observe linear regression, in linear regression, we had a scatter plot. But in logistic regression, we are having a plot, even though it is scattered, you are having data at two levels. One is at 0 and one is at 1. Is it clear? Are you understanding it? So basically, what we are seeing here, if you can observe this image, I'm just showing you an example. So if you can observe this image, when you're seeing this, even though you have plotted a scatter plot, I'm just trying to explain, you are able to see a scatter plot where you're having outputs at two levels. So one is at this level and one is at this level. So this is not a normal one. I think I'll show you a bigger image. But as of now, in a binomial logistic regression, you will have outputs which are two, which means you will have the data which is available in two levels. One is at 0 and one is at 1. So this is something which is point number 1. Now, having said this, you can see it could be binomial, or it takes both continuous and discrete input data, right? So, I mean, just ignore this, but just the objective is understand that there will be two levels. That is what I wanted to tell you right now. Nothing much apart from that. Fine. So, don't worry about the details of it. What I wanted to tell you is only this one, right? So, 1 and 0. Dichotomous means two outputs. Multinomial means multiple outputs. Dichotomous means two outputs. Multinomial means multiple outputs. That's all. Now we will go to the next one. Now let us say, for example, you have multiple outcomes here. What you saw here was like a single outcome. Now you have something called as a multiple outcome, right? So one is a single outcome and one more is a multiple outcome. Single outcome and multiple outcome. So whenever you have a multiple outcome, your probability things would come into picture, right? So whenever you have a multiple outcome, probability will come into picture, and then by using that probability, you will be able to define or probably do your analysis. So this is few steps that it will come, right? Slowly we will see how exactly we are trying to do. It will help us to classify the data. So these are some things that we are working on, right? Now, having said all this, we will try to understand this with an example. So what exactly is the example that we are looking at? So we are looking at example of a spam classifier. So you can see, all of you agree that whatever we are seeing, yes or no, is an example of a classification problem. So all of you agree that it's a classification problem, right? So now, since it's a classification problem, so what we are going to do is we will see how exactly things would work out here, right? So we'll see how exactly we are using it for our analysis. So now if you are checking this one, we will be having some kind of keywords, or we'll have some kind of methodology to classify it into a spam or no spam. Can someone tell me one or two methods how you can classify it into a spam or no spam? Just simple methods. So in case if you remember or if you know what how it is done. Correct. So there will be some keywords, as you are rightly saying, there will be some keywords which can be used to classify them. So based on those keywords, we will classify them into spam or no spam kind of things. So that is how it will work. 100% true, right? So you have a spam, no spam, and how it works, we will see in some time. Based on some keywords, as you said, here keywords will play a major role in classifying it into a spam or no spam. Now, let me take you through the example in detail and then we will see how exactly we are going to identify whether an email is a spam or no spam is by using few steps. As all of us know, the first step is understanding the variable. Means what all variables are there, how am I going to use them? So understanding that variable. Second step is plotting the labeled data. So basically you will plot the data. Third step is drawing a regression curve. And the last step is find out the best fitting curve using MLE. So MLE is maximum likelihood estimate, the estimate which is highly likely. So this is something, this is the steps that you will follow. Understand the variable, plot the labels, draw the curve, and find out the maximum likelihood estimate. So this is something that you need to be aware of. See, logistic regression at the back end is linear regression only. Why we call it as logistic regression is because you are using a regression thing or regression method to solve a classification problem. So logistic regression is also regression. Linear regression is also regression, but linear regression solves a continuous kind of a problem. This one solves a categorical kind of a problem. So that is the difference. So we are using this MLE to find out. So how we are going to do it step by step, we will see. Now, having said this, you can see here independent variable. So these things you need to understand a little slowly. Independent variable is count of spam words, correct? So independent variable means how many spam words do I have? So that is your independent variable. Here, the most common spam words are like buy, get paid, guarantee, winner, lottery, credit card. You remember all these things? All of you know what all words will be there in the spam mails, right? So these are all some kind of spam mails that we have, count of spam words. Now, exactly. So we have all these things. What we are assuming is all these things will come under something called as bag of spam words. So this is a hypothetical or probably a illusion. Okay. Whenever I get all the spam words, I'll put them into a bag. Just assume that you're putting them into a bag. It is called bag of spam words. So now, once you understand that this is a bag of spam words, how we are going to use it for our analysis is something that we are going to see now. Once you have this bag of spam words, how do you do it? So you can see here, this is the spam words. Now, the dependent variable is a probability of an email being a spam, which means yes or no, correct? 0 and 1. My question simple is, your independent variables are spam words. Dependent variable is a yes or no, spam or not kind of a thing. So now, when you have this independent and dependent variables like this, how are we going to use it for our analysis, and how are we going to do a classification problem? So if you were to see this image which is down, word count, the spam word count is there. Let us say, for example, you have 0 spam words in the mail. Is it not spam or spam? Normal mail or spam mail? If there are 0 spam word, not spam. One spam word maybe, may not be, no, can be, right? So one spam word maybe, may not be, but likelihood is very less. So some friend might have sent you congratulations on your promotion. So congratulations could be a spam word. So usually you would have gone to some place, you would have purchased something, they would have sent you some reward points. Or if you use Amazon, you'll get reward points every day. So that reward point mail also will have rewards, all that. But it may not be a spam, it could be a spam. Very less probability of being a spam. Similarly, if you have 2 words, then the probability of being spam increases. If you have 3 words, then it is more like a spam mail. If you have 4 words, doubtful. You have to check whether it's a spam mail or not. But you have 5 and above, let us say. I mean, I'm just giving you a hypothetical example. Don't go with this number, but just to understand, I'm telling you. In case if your mail has 5 spam words, then you classify it into a spam. Probability of that mail being a spam is very high. So you put it into spam. So similarly, you have 6, 7, 8, 9 and all that. So basically, if you have 10 spam words, then obviously it is 100% spam email. Correct? So this concept you are getting. Don't worry how many numbers to consider. We will see. No, we don't specify it. We will see all that. But understand these concepts first. Correct? So my independent variables are spam words.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Dependent variables are the classified thing, whether it's a spam or not. What I'm trying to do now is I am just counting my spam words 1, 2, 3, 4, 5, and all that. Based on spam words, I'm just classifying into a spam or not spam. If the spam words are less, it may not be a spam mail. If spam words are high, it could be a spam mail. So that is the object. So basically count of different spam words in a single email. Correct. This is clear to all of you? How do you identify how many spam words? Those things and all we will see in the next things. MLE I have not explained it yet. So once we come to MLE, I will tell you how we are going to do it. We're not doing this using MLE, but this is the concept. How we are going to do it is using regression. That I will tell you. 3 points that you should know here is independent variables are spam words. Dependent variable is a mail is spam or not, binomial. More the spam words, probability of a mail being a spam is high. Less the spam words, probability of mail being spam is less. That is what you are supposed to understand. Is it clear to all of you? Spam word means, so whenever you get an email, it can be classified into multiple types. One is a junk mail and one is a normal mail. So junk mail, we call it as spam. So here spam words is if your mail has buy, get paid, guarantee, lottery, rewards, winner. So all these things are some kind of a junk mails that we will get. Yes. So whatever mail it is unnecessary, that one we will call it as spam mails. Like you will have offer 50% discount by today. You have 1 lakh rupees and all that will come. No, free credit card, lifetime free. So they are our spam. Correct. Now, having said this, let me take to the next example. You can see here, I'm just marking mail into a probability of being a spam or no spam using my historical data. So let us say, for example, at today's date, you have, let us say 1 lakh email IDs in your Gmail. 1 lakh email IDs in your Gmail, correct? Total. In that 1 lakh email IDs, if you see every individual email, any email with 2 spam words is a normal mail. Any email with 6 spam words is a spam mail. 8 spam words is a spam mail. 1 spam word is a normal mail. So it's like that. If you count the spam words in every email and mark it as a spam mail or not spam mail, you will get a data set which is ready. So they say pre-labeled data set, but this is how your data set will become. So if you check a mail, let's say 1 lakh mails are there, right? So 1 lakh mails are there. In that 1 lakh mails, you count and then we mark it as spam and no spam based on what it is. So now why this is there is because most of them will be spam, but few of them may not be spam also. No, user will not scan any mails. I'm just giving you how a data set will look. So let us say you have 1 lakh mails in a mail box. We are constructing data based on two things. We are constructing as in we are not literally constructing, data will already be available. So spam or no spam kind of data based on our work. So what we are trying to do. So one is nothing but words, 8 words. In one mail, 8 words is spam. In one more, let us say genuinely you have won a prize. So that will sound like a spam, but it is not a spam. So if you really have won some prize, right? So this is how you get to label your mails. So let us say you have 1 lakh rows. In that 1 lakh rows, you will be marking few of them as spam, few of them as not spam. So based on the number of words it has. Clear to all of you? Any questions? Nice. So now this is what I am telling about the graph. So whatever I told you here, this one you observe I told na, this type of graph we will do it. Any type of word can be a spam or no spam. It's not compulsory that you should have 8 only. Don't go literally. You can have 2 words also can be a spam. That depends on the mail. So we are just trying to identify it, and then we are trying to see how we can classify the new mails, right? Now, having said this, you can see I have my data. I should plot it. So how am I going to plot it? I just take a cutoff, just a assumed cutoff. There are ways to identify this cutoff also, but I just take a cutoff of 0.5, and then what I do is all the variables are probably right. So what I'm just trying to tell you is, so we can see that when you plot these things like this, you will have some mails which are not spam and some mails which are spam, right? So any questions? How did I plot it and all that? If you have one, I mean, you're just taking one mail. If it is flagged 0, you're marking here. If it is not flagged 0, you're marking based on the words. You can see bag of words is this, probability is this. Okay. So let us say if I have one word, right? And then the mail is spam, right? So you have one word and then the mail is spam. How it will be? Why it will be? That depends on every mail, correct? So let us say that one word is click here to enroll. That is a spam email, no? If the sender is genuine and if it's not a marketing email, even though if you have one or two spam words, it will be classified as no spam. So let us say you're getting a birthday wish from your friend. So he's telling, wish you many happy returns of the day. Congratulations. I'm sending you reward points of Amazon worth 1,000 rupees. So that is no spam mail, even though if it has some keywords. But some things can be a spam mails without them also. Like as I told you, I am so and so from so and so country. I am having this much property which I want to give it to someone. So those kind of mails, right? So words doesn't define the nature of a email. They will only tell you whether it can be a spam or it cannot be a spam with a probability. Don't think that if I have one spam word, it will be no spam. No. If I have one spam, it can be a spam based on the mail, the nature of the mail. See, the understanding is very simple. I don't know why you are complicating it. The simplest thing is you will have some mails out of which you will have some spam words, right? So you will have some mails, you will have some spam words. Those mails can be classified into spam or not based on the nature of the mail and based on the spam words. If spam words are more, then the mail is obviously a spam one. There could be some exceptions. If spam words are less, it is not spam, but here also there could be some exceptions based on nature of email. Is it clear to all of you whatever I told you now? There is no way to differentiate. Very simple example. Look at your mailbox only. You will have 1 lakh emails. In that 1 lakh emails, you will have some mails which are classified into spam, some mails which are classified into normal mails. There could be one spam word, two spam word, any number of spam words in your mails. Based on the spam words and based on the nature of the email, it can be classified into a spam or no spam. Don't judge whether it is spam or no spam just by using 2 words, 3 words and all. That is not the case. Probably it can be a spam. It can be or it may not be. I can have one mail with 5 spam words. It can be spam or it cannot be spam also. I have one mail with 10 spam words. likelihood of it being spam is very high, but sometimes genuinely I would have won a prize, which means it is not a spam. Understanding all of you? Depending on the context. Correct. That is how you are plotting this. There could be one mail with lot of spam words, but it is marked under no spam. There could be one mail with less spam words, but it is a spam one. Google's forget it. Google's you can't go. Google's is a very complex algorithm. Till here, any questions? Bag of words, marking spam or no spam with some exceptions based on the number of words and plotting them here. This probability ignore. That's what I'm telling. If it is more than 5 words, then no spam. Less than 5 words, then spam. With some exceptions, obviously. Clear till here? All of you are clear till here? No one has any issues. Don't go to probability. Don't go to uh, how do I classify and all. Classification is very simple. If I have less than 5 words, it is no spam. There could be some exceptions. If it is having more than 5 words, it is a spam. There also there could be some exceptions. That's all. That is the criteria for my classification as of now. Is it okay to everyone? Clear? Yes, no, clear, all of you. So this is the objective. You classified it into spam or no spam, right? So you can see here, there could be one. This one is something which will be confusing. As I told you, na, you can see this one. Now, what happens is when I have exactly 5 words, that mail can either be a spam or no spam. The probability of that mail being a spam or no spam is equal probability. It's just an example for understanding. Correct. This is clear. Less than 5 words, more than 5 words, equal to 5 words. 5 words is a confusion state. You don't know what it is. It can be spam, it can be no spam also. Exactly. Just understand this idea. All of you are understanding this idea. See, you can't plot it at 0.5 because you have only two outcomes. Either it has to be a 0 or it has to be a 1. Irrespective of how many words, it should be a 0 or 1. So you don't plot anything in the middle. Yeah, we are plotting 5 in both places because you don't know, right? So I said 5, more than 5 is no spam. Less than 5 is, less than 5 is no spam. More than 5 is spam. I have not defined a state where words is equal to 5. So is equal to 5 is a confusion state. If you get a mail with 5 spam words, it can be a genuine mail or it can be a spam mail also. Clear, all of you? So this is the concept that we are supposed to understand, right? So this concept idea is important. So if you get this idea rightly, and then we can go to probability and all that, and then we will see. Fine. Oh, fine. So the next step, what we are going to do is, if you can see this, just like in linear regression, right? Linear regression, we were able to go ahead and then use it for our understanding, which was we were used to fit a straight line. Correct. In linear regression, we were fitting a straight line, but here, if we can observe, we are trying to fit a curve, right? So we are trying to fit a curve. We are not trying to fit a straight line. We are trying to fit a curve, right? So why am I going to fit a curve? Is because if you fit a straight line, you may not be able to get a right estimation. That is point number one. And point number two is there are two categories. So whatever you're seeing, there are two categories. And then if you want to like estimate for the two categories, right? If you want to estimate for two categories, you need to fit function which will address two categories. So straight line can address a continuous one, but what this thing does is it can address two categories, right? So yes or no. So those kind of two categories it can address. So that is something what you are trying to fit it now. Is this clear? Why am I using a curve with whatever I explained to you? If I use a straight line, you cannot address for all of them. So if I want to address for zeros, and at some point in time I need to address for one, because there will be two categories, I'll be fitting a curve. Cool, clear, understanding it? So this is step number one. Now we were seeing we have something called as logistic regression. So this logistic regression, whatever we are seeing here, if you can observe, there are multiple things. One is a log of odds, and the other one is, see, how we are going to fit is we are taking probability. Understand this, I will tell you slowly. You are taking 0, 1. 0 means not spam, 1 means spam. To estimate this, I'm telling you, no, there is something called as a logistic regression. So irrespective of what we are trying to do, it is a regression, correct? Irrespective of what you are trying to do, it is a regression, correct? Now if you want to do a regression, we are supposed to go ahead and then use a line. So that is what linear regression. So regression means you are trying to find out a straight line request. Now how am I going to identify this particular function? So where we were trying to get a sigmoid curve kind of a thing, right? So sigmoid as in we are trying to go ahead and then get curve, S curve kind of a shape. And now we are just going ahead and then finding a log of odds, right? So we have a sigmoid curve, and also we are trying to buy a log of odds. So how are we going to achieve that? So we are going to achieve that by converting our sigmoid curve into a regression problem and then fitting it into our probability. So these are two things that we are able to achieve, correct? So this is something I wanted to tell you, and then we will try to do this. Fair enough. Now what we will do here, if you can observe, is we'll just go ahead and then check how we are going to achieve this. So I'm not going to use much of the math because it may be a little overwhelming right now at this point in time. However, I'll be telling you how we will be able to achieve it, and then how we are going to do it with as less math as possible. So I want you to focus and understand properly. I mean, if you are trying to read the code or write the code, that is okay. Just ignore it. No problem. Right? So you just need to leave it right now, and then we will be able to achieve it. First thing, steps I'll tell you. We are planning to fit a curved line. So we may not be able to fit a curved line. So what we were trying to do is we are trying to fit a straight line first, and then from that straight line convert it into a sigmoid function. So right, so this is the steps. So you want to get a S curve here, so that S curve is called as a sigmoid function. So that is the name of that S curve. So I can't directly put a sigmoid here. So for that, what I'm going to do, step number one, I'm going to convert this particular case, or probably this particular state, into one state where I can fit a line, and then from there I will get back to sigmoid function. So this is the two-step process. Fine, this is clear to all of you. You're planning to go ahead and then mark a spam and a no spam. So you're planning to mark your mails into spam and no spam. In linear regression, we fitted a straight line. But here in logistic regression, we will not be able to fit a straight line because straight line cannot address this. So what we will do, we will use a S curve, so which can address this. So whenever my spam words are less, it will show it is no spam. When they increase, it will show it is spam. So we are going to fix that. How we are going to fix it is multiple step approach. First step is convert this into a way where you can fit a straight line, and then convert it back into a way where you can fit a sigmoid. So from straight line to this. So all of you know x-axis is bag of words. Observe y-axis carefully. Here I have 0, here I have 1. So here I have 0, here I have plus infinity, and here I have minus infinity. So this is one transformation. Again, from minus infinity to plus infinity, we are transforming it into 1 and 0. So this is a probability. So probability of mail being spam. So using sigmoid function. So this is something that we are going to achieve, right? Now, once you understood that two-step approach, converting into a straight line and then converting back into this, we will use log of odds. So what do you mean by log of odds? So we will see that. So basically, there is a simple example, right, which says a person who went fishing 5 times a week caught 2 fishes and failed to catch 3 times. A person who went fishing, he caught 2 fishes and then he failed 3 times. So what is the probability of odds of getting a fish, right? So you can see probability is nothing but chance by total chances, which means how many times you are succeeding in all your trials. Let us say you want to go ahead and then, yeah, you're also going for fishing, assume. Probability of success, probability of failure. So basically, probability of success is 2 by 5. Probability of failure is 3 by 5. Clear till here? Agree? Yes or no? Yes? Nice. So now you understood what is probability of success and probability of failure. Now, what do you mean by odds? Odds means in your total attempts, in your total attempts of fishing, how many times you are succeeding versus how many times you are failing. So that is the log of odds. Probability of success and failure is number of wins by total trials. Odds is nothing but odds means out of all the trials, how many are in favor of you, how many are not in favor of you. So that is your odds. This is called odds. Clear? Difference between probability and odds. Probability is nothing but success or failure divided by total number of trials that you have. So that is probability, right? So probability of success, probability of failure. Odds is nothing but out of all the chances that you are taking, how many of them are in your favor, how many of them are against you. That is odds. All of you understood this? It's simple. Now, right, let us go ahead and then see this where it is and then we'll explore. Now, let us say, for example, I'm just giving you an example. Okay, log of, let us say 1. Log of 1 is what? 0. No, log of 1 is 0. Observe this. Okay, I'll tell you. Okay, let me just go ahead and then mark it like this. This is spam. This is no spam. I'm just want to tell you the concept clearly. Now, let us say you have this particular spam and no spam. Assume you have how many here, total how many it will come. Let's say, I mean, n number of things. Let it be like 10 or 15. I'll take 5 by 5 here. Okay, sorry. Okay, I'll write it a little different way so that all of you can understand it clear. Spam and no spam. Let us say I have my total. I have total, assume, I'll take it for 20 emails. In this, 1 is spam, 2, 3, 4, 5 is spam, and I'll extend it to 20. Okay, I've extended it till 20. Now, if I have these many spam mails in my 20, how many of them will be no spam? This minus this, correct? This is my no spam, correct? Agree, all of you? This is spam, this is no spam. Here, what I'm trying to do, the next step is odds of spam. What is my odds of spam? Odds of spam is nothing but spam by no spam, correct? 1 by 19. This is my odds of spam. So I just need to add another line here. This is really important. There could be no spams also. There could be 20 spams. I mean 20 no spams is equal to this by this. Correct? Fine. Till here. No, this is the number of mails, not the word count. Spam mails and no spam mails. So what I did is I took 20 mails as an example. In that I did all the combinations of spam and no spam. Zero spam, zero no spam. And then we are just writing all of them. So how many can be spam and how many can be no spam. This is odds of spam. Now, if I take, I'll not take odd of no spam, not required. So if you want to do an odds ratio, then you might need, but anyway, let us take that also, no issues. Let's try. If I were to do that, odd of no spam, so which will nothing but 19 this by this, correct? So you're getting a reverse of this. You will not get anything. You will just get a reverse of what you saw here. You'll get this here, this here. It's a reverse. Clear? Odds of spam by no spam. Clear to all of you? Now, odds ratio of spam by no spam. You can see here. Okay, I need to take a log of odds. That is okay. I'll just do that. No, don't worry. Log of odds and log of, I can take a ratio and then take a log. That is also same only. Correct? I can take a ratio of both and take a log, or take log and take ratio. I'll take ratio and take a log. So better. Odds ratio of spam and no spam is spam by no spam. Correct? Agree? Spam and no spam, right? Now, if I check this, let me just take a simple example. You can see it is going like a exponential, correct? All of you agree? It is going like an exponential. Log of odds ratio is going to be an exponential curve. I'll remove this. I just wanted to show you. I just deleted. Fine. Now, my log of odds ratio is equal to log of this. I take a log of this and then I make it into 2 decimals and then I plot a line graph. So whatever was exponential, when you take a log of odds ratio, it will become linear. See, interesting. This is precisely what is going to. Now I am enjoying, right? 0, 1, 2, 3, 4. There are this is how it works. Okay, I'm not using any video, I'm not using any tutorial. I've taken open explanation. I've just opened yeah, it is just pure Excel sheet, so nothing much. This is what happens in the logistic regression in the backend. Now my next question is, you saw there were like dotted lines which were going up. Can you fit a straight line to these dots using linear regression? If I were to say, if I were to ask you now, you know, where is regression in logistic regression? Understood this concept? Base is always linear, correct? That is why I converted it into a, these are spam mails, these are no spam mails. You don't need to convert, your machine will convert. So we just need to understand the concept, that's all. Whatever I'm doing, Python will do internally. You don't have to do, but you need to understand how it works. Right? Till here, is it clear to all of you? How did I get this particular thing? Now, my question is, we took 20 emails, we got 20 data points. Okay, correct? What if I take 1 crore data points? If I take 1 crore data points, you will get some number on the top, some number on the bottom. Very huge numbers you will get. No? Is there any limit that I should take that, okay, no, I can run my logistic regression only for 500 data points? No, right? So what is the range? Infinite. You can put infinite. Middle will be 0, top limit will be plus infinity, bottom limit will be minus infinity, correct? Now let me just keep this aside. Okay, I'll just do an undo for this so that this graph is gone. So here you get a log of odds ratio. Log of odds ratio you get. Now this is clear to you now. Whatever was this 0 in the middle, your dots will come here, 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 here. If it is below middle point, then it's a no, it's a spam. I mean, it's a no spam. If it's above, then it's a spam. So something like that. Log of odds ratio, we got it, right? So this is nothing but log of odds is log of p spam by 1 minus p spam, right? So this is basically probability you will get something and all, you will get it here. Don't worry about all the substitution and all that you will do, and then you will get something wonderful. according to this slide, but I don't know. Let it be here for the time. We will understand the things better. Now you get a plus infinity here. That is what I told, na? So you just take so many data points, you'll get plus infinity. If you take less data points, you'll get minus infinity. This I'm evidently showing you here only. Divide by 0. Now this is infinity. This is also infinity. This is minus infinity. This is plus infinity. You can see from 0, it is increasing, going to infinity. Increase, decreasing, increasing, going to plus infinity. So that is what they are trying to explain here.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So leave that. Now you're plotting log of odds ratio. Whatever you plotted, no, your spam, no spam that will come is nothing but a log of odds ratio, correct? Once you have that log of odds ratio, what we will do is we will spend some time with the Excel sheet again. Just hold on for a few minutes. You have plus infinity, you have minus infinity. You plotted your log of odds ratio, correct? Your mail, whatever your spam mail that you're checking, no, it can be anywhere between 0 to infinity. It can be at this point, this point, this point. You can see now in this one, you can see based on the probability, these are equal. Means I told, right? These are equal kind of scenario. Same words. So confusion state. So 0 and classify. Here it can be anywhere between 0 to plus minus infinity, 0 to plus infinity. The range I'm talking about. You can see 0 to plus infinity, 0 to minus infinity. It's the range. Now, what we will do is, if you want to give, you converted it into a linear function. Okay. You converted into a linear function, log of odds. Now, you have to fit something. It can be a straight line, curved line, whatever it is. You converted your data into a linear kind of a data, which means you can do a regression on that. Linear regression means you will fit a linear straight line. Now you want to fit one line which can help you, right? So that function which can fit this is a sigmoid function. It's not a straight line function, it's a sigmoid function, correct? So now you are changing the axis from infinity to 1, from minus infinity to 0. Axis would change, right? So we'll see how it works. What does sigmoid function means? So sigmoid function is a standard logistic function. Logistic function e power something, e power something. What I'm trying to tell you here is, to convert something into a log, you will take what? You will take a log. To convert a log back, what you will do? You will take e power exponential. Anti-log, you can take e to the power, right? So exponential, e power you will take. Correct? Natural log, log to the base 2. So there are two types. Anti-log is e power. So I'll just put here, I don't know if e power works on this, xp, exponential of this. Let me see if this works. If not, we will check and then we will see later. No issues. So if this works, fine. If not, then I will see how it works. You can see same thing, no? I reduce the decimal point, so that's why you're getting little different. It's an exponential. Yeah, it's an anti-log. Whatever the data previously was in exponential, we converted it into linear, and now we are converting it back into exponential. So this I don't need. I just wanted to show you. E power will convert it back into a linear. Clear till here, all of you? Any questions? Nice. Now this slide is a little important. So the equation of sigmoid function is e power x by 1 plus e power x. Sigmoid function is e power x by 1 plus e power x. So this is my sigmoid function, or the S-shaped curve that we talk about. Whatever we were seeing has an infinite limit, which means your range can go from 0 to infinity. But the functionality of sigmoid is, it will become 0 if your value approaches minus infinity. It becomes 1 if the value approaches plus infinity. Irrespective of how big or how small it is, this is how it will work. Now, you can see here, any number you take, real values, it can be mapped between 0 and 1 using sigmoid function. Any number between 0 to infinity can be mapped. Anything between 0 to minus infinity can be mapped, which means you are taking your complete range from minus infinity to plus infinity, and then you're mapping it into 0 and 1. This function is your logistic regression function. Agree? Now, clear? Conceptually, you're getting it? Following? Nice. So now what we'll do is like we'll go ahead. Yeah. So what I was saying is whatever distribution that you created here, its range is between minus infinity to plus infinity. If you want to do fit a line, fit a curve, do whatever, you will not be able to do it within minus infinity to plus infinity. Now, if you want to get it inside a range where you can fit a curve, that range is 0 to 1. There is a math function called sigmoid function. Its range comes if it is minus infinity, then sigmoid function approaches 0. If it is plus infinity, then sigmoid function approaches 1. And everything in between can be fitted. So that is why we select sigmoid function to do our logistic regression. Clear? Fine, all of you? It won't go in negative or also in positive. It will not go to minus infinity. No, it will not go into negative. It will not go into minus 1. Correct. It is only 0 or 1 because we should identify 0 and 1 only, no? Binomial. That is why use this sigmoid function. So now how we are going to use it? Okay. Right. So let us go ahead and then see next what is going to happen. So we saw minus infinity to plus infinity and then you're getting a sigmoid. How is probability is nothing but e power log of odds ratio by 1 plus e power log of odds ratio. Just see this probability of something happening to something not happening. E power 1 plus e power log of odds ratio by 1 plus e power log of odds ratio. Now what I will do is I will do something called as probability. Probability is nothing but e power this divided by 1 plus e power this. Is there any mistake that I did? It's not 1 plus, no, it's 1 plus only. Correct. E power log of odds ratio by 1 plus e power log of odds ratio. That's what I did now here. It's natural law. Anyway, this is supposed to be, do I say, 0 and this is supposed to be 1. But anyway, let us plot this and see you will get a sigmoid curve or not. It's like base 1, base 2, such stuff. But anyway, let us plot this and then see whether we'll get a sigmoid curve or not. Next, finish. You can see you're getting curve which is straight like this. Probability from 0, I'm bringing it between 1, correct? You can see now probability I got it from 0 to 1 right now. That is what is here also. Probability is between 0 to 1, correct? Agree with me? Now, if you can see this, I'll just put it like this. This one we tried. Now what I'm trying to do is I'm just checking negative and positive. All negative numbers, whatever you have are spams, positive or no spams. Same thing, I think with us also. You can see negatives are less than 0.5, positives are more than 0.5. Now what we are trying to do, I'll just put it again and then I will show it to you. All the points which are below this become 0. Why? The probability of them being a spam or no spam is less, which means probability of them being a spam is less. So I can mark this also as 0, this also as 0, this also as 0. All of them I can mark it as 0 till 0.5. Agree? What we saw here on the top, I'll show you where we saw that. Here, probability, if it is less than 0.5, then you mark them as zeros. If it is more than 0.5, mark them as ones. Now, whatever image you are seeing here, the same graph I plotted here, 0.5, 0, 0.51. Whatever is less than 0.5, mark them as 0, which is not spam. Whatever is more than 0.5, mark them as 1, which is spam. Correct? This one. Agree? Till here, agreeing? All of you, concept you are getting, no? This video you have to see multiple times, only you will understand, or else it will be difficult, okay? So now once you do that, so till here you got it. This also is done. So this is spam, this is no spam. You're just plotting them like this. Once you completely plot it for all of them, you can just plot their probabilities here 0 0.1, 0 0.3, so on, so on, so on, so on, so on, 0.99. So same thing here also. You can see 0.7, 0.1, 0.4, so on, so on, so on, so on, 0.99. Same thing here also it has come like this. Now we will find something called as a likelihood, which means whatever you're getting here, probability of something being a spam or no spam is called likelihood. This is likelihood. How likely it is a spam. So I told you this is a probability, right? So there is a chance of 50% that this being a spam or no spam. There is a chance of 30% this being no spam. I mean 70% that this being no spam and 30% it being a spam. So like that. So all these things are not spam. All these things are spam. There is an associated probability which is called as likelihood. Now what we are trying to understand is you get all these data points here. Now you can see you are supposed to do it like this. Likelihood of a given data. What is the likelihood of given data? 1 minus 0.01, 1 minus 0.01, 1 minus 0.01, 1 minus 0.05, 0.9999, all these things. This is nothing but if it is less than 0.5, you are doing 1 minus because it is no spam. This formula, see this formula, not this. This is your likelihood, log likelihood, log of likelihood, log of odds. This is likelihood function. Log of odds is nothing but your log of likely logic. You can see same thing. Now what you're trying to do, p of spam by 1 minus p spam. This is the ratio. But now what you're trying to do, the complete likelihood you're trying to identify. Individual log likelihood of each email is this. Now likelihood of the complete data given this curve. So if this is the curve, what we will get? 1 minus 0.5 till here into this one. So you just supposed to multiply all of them. If you do this and then take a log of it, right? Take a log of this likelihood, then you will get the log likelihood of this particular line that you're fitting is 0.85 or minus 0.85. So log likelihood of that, this concept I'm not doing it in Excel because it'll take a lot of time, but just understand. Till here, is it clear to all of you? How do I find the likelihood? Clear? Likelihood is nothing but the probability that we calculated here. So this is the likelihood. What is the likelihood of some mail being a spam or no spam? That's all. Probability is likely. If you see this, let's say this, in here, there is 0.07% one mail, some mail is a spam. Here in this set, 93% of mails, the probability is spam. That is the one, right? So likelihood is nothing but the probability. So what we calculated here. So you can see likelihood or probability is e power 1 plus e power logs order ratio. So e power logs of order ratio by 1 plus e power logs of order ratio. Yes. Are you understanding till here? Basic calculation. I'm not doing any complex stuff. Let me be very clear. I took mail set of 20 mails. Okay. I took set of 20 mails. I took all possibilities of being spam and no spam. I found out the odd of spam. You know how to find out odd of spam. I found out odd of no spam. Odds of log you did. I mean odd of spam, odd of no spam, odd of ratio, spam by no spam. Then you took log of odds ratio. Then you took probability. So how do I find probability? I have to take e power x by 1 plus e power x. Now I'll tell you one very simple concept. Till here is it fine? Flow. If you see the video once again, you'll understand how the calculations are done also. That's it. It is binary as of now, 0 and 1. I'll tell you what does that signify. I'll tell you. Whatever you are seeing here, this probability is this column, probability I column in Excel. True. So now what I'm going to do is I'm going to tell you we are just doing a simple calculation. Okay, for all these ones you have 0.1, 0.1, 0.99, all these things. Now we are going to take likelihood of data. Likelihood of data means whatever is less than 0.5 you are subtracting it, and then whatever is greater than 0.5 you are just having it like that, 1 minus and 1 plus. So something like this you're trying to do. Once you do this particular calculation like this clearly and then take a sum, take a log and then take a sum, log likelihood, you will get a value which is 0.08. So this calculation will try to do it. This is the likelihood line that you will get like this. The log likelihood of this particular line is this. There we were in linear regression, we were having a line where we were trying to minimize the error. Correct? Agree with me, all of you? We were trying to minimize the error. Here also we'll try to do something. So this is one line for which the log likelihood is 0 minus 0.084. Correct? So in linear regression, we were trying to minimize the error, actual versus predicted, and then find the best fit line. Here, there is a likelihood, which means the log likelihood of this line is 0.084. So this is something that is coming. This is the line that you're trying to fit. Now, if you take another line like this, first line was like this, you're trying to fit the first line. You can draw infinite lines, no, here also. It is not fixed to a single line. You can draw infinite lines and check. If you change your line like this, and then again find out log of odds ratio, you will get some value, minus 0.27. If you change this again, let us say one more line. Here line A is 0.085, line B is 0.024. Similarly, you can have multiple lines like this. Correct? You can have multiple lines like this. You can just keep on taking multiple lines, fitting multiple lines, and then finding the likelihood where you get the maximum likelihood. This is called as MLE, maximum likelihood estimate. Whichever line will give you a maximum likelihood estimate, the sigmoid curve corresponding to that line is your best fit curve for logistic regression. Is it clear to all of you? Conceptually, you got it. Will logistic regression will not give MLE. Logistic regression is nothing but it will not give MLE. You need to find the maximum likelihood estimate using your straight line. So for every straight line, you will have an associated sigmoid function. When you have log of odds ratio, it is a line. When you take e power x by 1 plus e power x, that's a probability. So every straight line will have an associated sigmoid curve. So when you plot all of them, every curve also will have a MLE, maximum likelihood estimate. Whichever line gives you a maximum likelihood estimate, that curve is your correct fit for logistic regression. So this takes some time to understand. See the video multiple times, you will get it. Are we clear here? We will get the same line. See, when what I told you is for the spam and no spam mail. So whatever data that you are getting is for spam and no spam. These are the data points that we plotted. For this data points, you can fit multiple lines. No, I'll give you an example. I mean, just in case you are confused, I'll give you an example. Okay, let me just give you an example. Fine, no issues. I'll just plot a graph. You tell me how many lines I can fit to this particular curve. I mean, to this particular data, how many lines I can fit, you tell. How to fit line means you can just take estimates, like you just assume that this line, this line, this line, like that. So you can have infinite lines, but one will be the best fit, correct? Just like linear regression, same linear regression concept is here. You can fit infinite lines, correct? And again, see the same concept. If you want to fit line to this, you can see what is the average of this. Same average of this particular table, 10. Same thing. If you just do it here, this will also be 10. So your first point in linear regression is what? 10 by 10. So your line should pass through 10. If you put a graph here, whatever I showed you, y is equal to mx plus c line, you get one value here already. You already have a 10 by 10, 10 comma 10, you will have already one line. You have to have one line. You can see 10 comma 10. This is the middle one. Not supposed to take this also. Spam and no spam. So it is actually no spam and spam. So you will get a positive one. Since you have taken spam, no spam, you're getting negative. So your one line will always pass through this 10 by 10 mean point. You can have so many lines for this. I've just taken a proper example, so that's why I'm getting a line. But if you take random numbers here, then your dots will be here, scattered around, right? One point will pass through 10 by 10. Where the next point will pass, it will pass at the intercept. So make your y value 0, make your x value 0, see how many spams will come. So if it is 0, then it will pass through 0 like this. So like that you can have multiple lines. So whichever line gives you maximum MLE. For this line it will not change. For this line it will be same only. In reality, when you take multiple data, multiple random scatter plots, no, it will not be overfitting. It will not be overfitting here. Maximum likelihood estimate is what's supposed to consider, right? So whichever line gives you a maximum likelihood estimate, that one will be, it's not different columns, different rows in that column will be different line. So when you have those multiple things, whichever line gives you highest likelihood by calculation, so like this, if we do that one, we will consider it as a best fit sigmoid function. Correct? Fine, all of you? Nice. So what we are going to do now is we are going to take a data set, and then by using that particular data set we will continue, and then we will use our logistic regression in that. So I'm just giving you the data set. So step by step we will see how we can achieve things in logistic regression. There are few things which I would want you to do, and then there are few things that we will do together, and then we will go ahead and then build it. One thing that you need to understand in today's session is you will learn something very important, which is called as a confusion matrix. So I'll teach you what is confusion matrix, and also I will teach you what is a ROC curve. So ROC curve also I will teach you, and then we will see all that, right? So these things and all we will consider in today's session, and then we will start, right? So confusion matrix and all of that are important, very important. So let us go ahead and then do it. So before going to that, so today we are going to implement the logistic regression using the code. So today is the coding part, right? So hope all of you are okay with the linear regression one. So we are going to do the logistic regression in the form of code. Cool. So now what we are trying to do is we will understand this data set first. So what is this data, right? So if you can see, you have some variables which, there are some variables which you are seeing. So you can see age is in years, gender, CP means chest pain type, test BPS which means resting blood pressure. So T rest BPS means resting blood pressure, col means serum cholesterol, FBS means fasting blood sugar, rest ECG means resting cardiographic result, which means what is the heartbeat cardiography that you get when you are resting. So resting cardiography. Then thalak means maximum heart rate, right? So that is a term. Then you have something called as exang. Exang means exercise inducing agnia, some kind of what can I say, disease or something, so that they are having it. I don't know the exact meaning of that because they are medical terms, but they're all our X variables. Old peak means depression induced by exercise relative to rest, that is one. Num, 5 levels of variable. So 5 levels of variable, which is v0, v1, v2, v3, v4. So all these things. A location, you can see which hospital they are, from where it is captured. So these are some of the main attributes that we have for the data. So here, what we are trying to do is we are just going ahead and then checking out our X variable and Y variable. Now you understood the data. You need to understood what is my X variable and what is my Y variable. So to do that, what we are trying to do is we will just go back to our, that's okay. I just took a data dictionary. It may not be the same. In case if you don't have it, that is fine. So this is a little limited one. They have given you the target. So there's a small change. So other terms are there, right? Just to understand the other terms, I took that. right? So data set, you don't worry that it should be the same. It is like a little different. That's okay. Now what we are going to do is, there are two major things that we are checking here. So you can see clearly you have something called as a target. So what does the target mean? Target means the person who is having 1 is highly likely to get a heart related issue. A person who's having 0, he will not get any heart related issue. So these things are something that we are getting it right now. So now once you have these, import pandas spd, read it and then do it. All of you are able to read it. Can I get a yes or no? Using the same code, keep the file in the same location and then read it. Fine. Cool. So if all of you read it and now you understood. Now what we are going to do is, just like how we built a linear model for a price, we are going to build logistic regression model for our heart related data. A basic classification model is what we are going to build right now. How are we going to achieve that is something that we will be seeing now. Right, so you have pandas pd heart csv. Now the first step in this is, we will just go ahead and then explore the data. So you can just go ahead and then do all the describe functions and all that and then see. But what I'm trying to do is, I'm just trying to explore my data. So there are 303 rows, 303 patients and 13 columns. Out of that 13, the last one is my target. So the first thing that I'm going to do is, I'm just going to just do a value dot counts. If you can see, this will give you differentiation between your ones and zeros, right? So can you do this? I'll tell you what is the significance of this. Can you just do it? Once you're done, you can type completed. So the main thing that we are looking at here is, we are checking what is the proportion of my positive and negative data. So when I say what is the proportion of my positive and negative data, I am just seeing whether the data that I am checking is imbalanced or not. So what do you mean by an imbalanced data is, whenever you have your ones very less compared to zeros. Understand this, whenever you have ones very less compared to zeros, that is called as a imbalanced data, right? So which means your value of ones will be very less. So usually those kind of things would occur in these places, right? So you'll get them very often. So that is something I wanted to tell you. It is imbalanced. Now whatever data that we are using is not imbalanced, because you have almost a 50-50 percentage. Are we okay? The bracket you should use is a round bracket. You have used a flower bracket, so that is why you are getting a error, right? So all of you got the importance why we are checking this particular thing. If you have very less, let's say maybe 1%, 2%, like that, then it is called as a imbalanced data, right? Value counts will give the number of value counts, correct? So if it is imbalanced, then we have multiple ways to deal with it. So we can go ahead and then do a sampling, under sampling, over sampling. So that is again a completely different thing altogether. I'm just telling you for your understanding. These things you can go ahead and then do. So I'm just giving you an estimation of the imbalanced data. So if the data is imbalanced, you can go ahead and then do multiple ways of arriving at it, and then you will be able to achieve it. So that is something I wanted to tell you, right? So under sampling, over sampling, multiple techniques are there to handle it. This is not imbalanced because you're having an equal kind of a data. So this is not an imbalanced data. So let us go ahead and then see how exactly we are going to achieve this. So now what we are going to do is, we are understanding it that the data that we are using now is not an imbalanced one. We can proceed further and then we will be able to use it for our analysis without any issues. So we understood that, and then now currently what we will do is, we will just go ahead and then see how this can be used further for our analysis. So we'll just go ahead and then check that, and later we will see how it can be done. We will go ahead and then check plot how our target looks. This is also a continuation of the same thing, how we are going to use it for our analysis. So basically whether we are going to take it and then check whether it is balanced or imbalanced, that one. So we are just checking this out. So I request all of you to please do this as well. Just plot it using this one. It's not compulsory if you have done the above, but for the sake of completion, please do it so that all of us are in the same page, right? So we can just go ahead and then do it. Once you are done, please give completed. Yes. So it is just giving you a visual representation of what we saw. So nothing much, but let me run this and then we will see. Right. So you can see you're just looking at it at a visual level. So you're not looking at it anything else. So it is just a visual representation of whatever we are seeing. So that's it. So what we are trying to do here is we are trying to generate a bar graph. The bar graph, what you are seeing here, is mainly used to visualize the target variables.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So how many target variables are there? So this is as good as the previous one that we did, the value dot counts. It will just show you whether your target is a balanced one or not. So whether it is good or bad, it will just show it to you. Right. So nothing much apart from that. So it just gives you a basic understanding of this. Fine. Right. So this is just a visual representation. Now, once you have completed this visual representation, so we will just go ahead and then check how we are going to separate our data with respect to target and our independent and dependent variables. So we can see we are separating our data into dependent and independent variables, right? So can all of you try to do this? I've just given you the code. Can you just try to do this? Yeah, these are the variables, right? So if you have taken the screenshot, so you have to split their x and y variables. Take a minute, all of you, do it slowly. Yes, x is equal to independent, y is dependent. So that is the standard that we follow. Yes, cool. Take your time slowly. You can use capital X and small y generally. Yes, that is the standard that usually they follow. I mean, having said that, it is just a standard. So you don't say like this is how it should be and this is how it is. Just to maintain a standard, we are having it. So it's a markdown cell. So you have to make it into a markdown. So you can see cell is there, no? Cell type, if you convert it into markdown, it will come like this. So once you split this, you're having basically a x and a y, which is already created. Now, what we are going to do, we have to do something next. So what is it that we are going to do it? Can someone tell me? Any guess based on what we have learned till now? You want to take any guess? Yes. So basically, we want to do something called as a train test split. So why do I need this train and test split? All of you are aware. Train and test split, we need it because we want to train our model on some data and later we have to test the same model. So once we train it and once we test it, we will be using those things for building our model. So basically training and testing is the process that we usually use. So that's why we will use that. Cool. So we'll just go ahead and then see how we are going to make this thing happen, right? So we see what is our x and then we see what is our y. So basically you get all the variables into this and then you will be getting just one extra thing, which is your target into this. So these are two things that we will get it and later we will just check how things are working at this point in time. So now, having said all these things, we will just go ahead and then see how our analysis and how our functions are working. So let us just go ahead and then do a small deep dive into this one and then we will just go ahead and then see how it works, right? So we can just go ahead, do a very small deep down and then see. So see, there are multiple things that you can do. So you can check correlation, you can remove them, you can do all of that. What you said is right. But our concept today is to build a logistic regression. So that is why we are entering into directly building a model. So when you build a proper model in reality, So what you're supposed to do is you have to do a full-fledged EDA. So if you remember, we did a EDA in the previous sessions where we were checking the every variable, what is skewness, what is kurtosis, something similar to that. We have to check every aspect of the data and then build a model, right? So but now since we are understanding logistic regression, so our objective is a little different, right? So that is something that we are trying to do. So it is like learning a small snippets or small modules, and then in reality putting them all together, right? So that is something that we will do it. Now we understood X and Y. So now we are splitting it into the training and testing data, right? So can someone probably take a guess what did we use to split our data into train and test data in our linear regression? This is something that we would require. Can you just try that out once? I'll give you 1 minute. Try how to split it into X-ray and X-test. I'll give you 1 minute. Yes. So most of you, whatever you have done, I think you are able to get it. So whoever has done X-ray and X-test, white train, white test, so that is good. Now, what I will do is, I will just show you how exactly we are trying to achieve it, and then we will see. So now, the next step, once you have train and test data set, is building a model. So you have to just build one model. XY where we feed the data to split. Correct. So into X and Y you are splitting your data. You're right. So what we're going to do now is once you have this, you're going to build a model. Right. So how we're going to do that, how we're going to use it, that is one thing that I will show you. So these lines I will show it to you. This would be a little challenging, I will explain you few things here. So you can just start with this. I will explain you couple of things. Let us see. Right. So you can just see this. Just try to use this code. There are some things which I want to clarify to you in this one. I will do it once you type all these things completely. Okay, that's good. So you'll understand this in a little detail now, so that all of us are aware. So I'll tell you slowly. understand what it is and then how we are going to use it. So basically, let us start from our sklearn dot linear model, import logistic regression. So what exactly that does? Can someone tell me? Take a guess. First line. So that one all of you might should know, right? So basically, your sklearn has a function which is called as logistic regression. Correct. That sklearn function will give you all the things that documentation. So I have multiple types of solvers. So what those solvers do, something we will go ahead and then understand. Sklearn logistic regression documentation, right? So I'll just go here. So you can see there are so many things that come in default. These are all the parameters. For me, solver is something which is important, right? So solver, what it does is it is a mechanism to find the best fit curve. Solver solves the problem to find the best fit curve. So I'll show you here so that it is detailedly explained. Why I'm showing you all this is because I would have just told you like that. Few things I don't remember, point number one. And second thing is, if you want to find out on your own next time, you should be able to see it. You should be able to understand from where this thing is coming from, right? So with that objective, I'm just trying to tell you. So, right, yeah, you can see there are multiple things that are there in solvers. So basically there are 4 or 5 types of solvers. You can see liblinear, Newton CG, SAG, SAGA, and LBFGS solvers. So what are these liblinear and all of that? We will see in the down. So I'm not going into the detail of every solver, but just understand how exactly these things should work, right? One solver is used for one purpose, so which is listed here. I'll show you. There is a place where they have listed all the solvers so that I can just show it to you. You can see here. So these are some of the solvers. So what does LBFGS stands for? It stands for large scale bound constrained optimization, which means it will find out your best fit curve based on certain criteria using large scale bound constraint optimization. Now, liblinear, a library for large linear classification. So if you can see, we have used something called as liblinear. Liblinear is a linear classification solver. So which means the method that we learned, right? Using linear regression, we are fitting a curve, right? Sigmoid curve we are fitting using a straight line. So that is your liblinear. The reference is there. All of them are some international universities where papers are given, right? So SAG is based on a gradient descent kind of approach. So this is stochastic average gradient. SAG stands for. So this is based on gradient descent approach. And then Saga is again strong convex optimization. So this is fast. So there are various ways of finding a same sigmoid curve. So optimizing different types, right? So this is what a solver means. What we have used is a linear solver, which means the method that we used, right? We found out log of odds and then we did all that. That's a liblinear. Similarly, there are different methods by which you can find the same solution of sigmoid curve. So that is your solver. I'm not going into everything in detail. So I've just shown you how you can just get it, right? So does this answer your question? What is solver? So some solvers would help you some solvers would help you to get better results. Some solvers have some constraints. So just like I'll tell you, based on your problem, you can use some solvers, you cannot use some solvers. So I'll tell you what is it. So if you can just go to logistic regression here on the top, they have mentioned what to use, what not to use. You can see the Newton CG, SAG, and LBFG solvers only support L2 regularization with primal function. The liblinear supports both L1 and L2 with duality formulation. So this is something which this you will get it when you go into depth. So this you will not get at this point in time, right? So there are some constraints. So what is L1 regularization? What is L2 regularization? So those things and all you have to go ahead. So everything is mentioned here itself. So you can use and then you may do that. Here, if you can see in multi-class training algorithms, multi-class set uses cross entropy multinomial. Currently multinomial supported by only by LBFG, SAG, SAG, Newton CG solvers. Multinomial is supported by these, right? So if you want to use binomial, let us say linear, right? So client regularly using these things, right? So these some things you need to read, and then based on your problem statement you can use it. So you can't use any other solver. I mean, you can use it, but you cannot use liblinear for multinomial because it is not supported. So something similar to these things, you have to go through all these things in detail, right? So you'll get all the resources. I'm just showing you how this works, correct? So we're not going into the complete detail of it, but as of now, since we used a linear approach, so we are using a linear solver and we are solving it. Is this fine to all of you? Anyone has any questions at this point in time? Are you following it? It'll almost be similar only. It will not be like different, but the performance will vary for each solver. Liblinear only most of them will use. If you don't use solver, default it will take. So there's no issue. So you can see LBFGS is some kind of optimized way. So it stands for large scale bound constraint optimization. That is a different way of doing it. Default is the linear one. All of you getting it? Are you following the steps, following the flow? So now if we were to go ahead and then check the things that we were seeing, we'll just go ahead and then, right? So this is how you create your logistic regression model. You created your logistic regression model and then you have done it. So nothing to worry because everything your data takes care at the back end. So your model is done. Now you are just doing a prediction. So predicting the results. So you can see predicted log model dot predict of X test. So you're predicting it based on your X test. Can you run this? Take few minutes. So you're just trying to predict. So how many values are there in the test, those many you will get. So I have taken 20%. So that much I will get. Yes. So what I will do is, once you have done this, there is one important thing that we will understand today. Before that, all of you are able to achieve this? Cool. No problem. So now, next thing is we need to find out the accuracy. So you can see you're getting a model with 73% accuracy. Can you try this out? Accuracy may vary, no worries, but you got it right. Nice. Very good. All of you others, are you getting this? Cool. Now, you have done till accuracy. So now, if you can observe, there is something called as a evaluation criteria. Okay. So there's something called as a evaluation criteria. There are two things which we are taking. You can see here. Understand this carefully. From sklearn metrics, import confusion matrix. From sklearn metrics, import classification report. So basically, so these two things we will use to find out how accurately my model is performing, correct? I'll also show you how this number can be got. I'll ask you to do a small math now, just a small calculation. Just observe this carefully. So just like how you had sklearn dot linear model, sklearn dot linear model is a folder where you will get logistic regression function. Similarly, sklearn has multiple metrics. So when I say metrics, metrics are nothing but the functions for measuring model accuracy. So sklearn metrics, you import confusion matrix. sklearn metrics, import classification report, right? Confusion matrix, you have to compare between y test and y pred. So if you compare y test and y pred, you will get a confusion matrix using which you will be able to do that. Cool. These two things I have not gone into detail, but just letting you know. Are you getting these two lines? Correct. So you're basically doing it. Yes. But now what we are trying to do here is, if you can observe, one thing that I want you to understand is you're comparing and then getting our test and predicted values. Now, if you run this, just run this, you will get a small matrix kind of a structure. All of you got this? Slowly do it, no problem. Slowly do it. Just observe, I'll show you one thing. how exactly this works. Your accuracy, you got it by using log model score 73. Here, this you cannot remember always because this is not a standard form. Okay, so this is not standard form. This one is a standard form. Any classification model. So this is a standard form of identifying. So the first thing what I want you to do whenever you get a confusion matrix. So what is the total here of all the four numbers? 61, correct? You're getting 61, right? Now take the diagonal elements 20 and 25, which is 45. 45 by 61 is how much? Just divide 45 by 61. Are you getting your accuracy score here? So this is the standard way of identifying accuracy. So confusion matrix will give you all the things that you want. So one link I will give you to understand confusion matrix better. So that link is Wikipedia. So this gives you a full understanding of your logistic regression confusion matrix. So you can see there are true positive, true negative, false positive, false negative. All these things will come. For us, what is the confusion matrix that we did is, you can see, just compare this. Okay. People who have cancer, you're identifying them as cancer. People who don't have cancer, you're identifying them as no cancer, which means these two things are your correct predictions. So what is the accuracy? Correct predictions divided by total is your accuracy. So 6, 7, 8, 9. 9 by 12. 9 by 12 is my accuracy. So this is simple, one level. Now, what are these called as? So this is called as true positive. This is called as true negative. This is called as false positive, which means when a person doesn't have it, you're telling he has it. That is false positive. When a person has it, you are telling he is not having it. So that is false negative. So both of them are errors. So this is one basic level understanding of confusion matrix. Apart from that, you have multiple things which is called as sensitivity, specificity, precision, all these things you will have. So you can just go through this, and whenever you want, you can use. These things are nothing but a combination of these only, mix and match of this. I just told you about this small table. Got it? Exactly. Confusion matrix is something that is required. True. Cool. So basically, if you can see, 20 and 25 are correct predictions. 10 and 6 are false. So 20, when it's yes and yes, you are getting 20. No and no, you are getting 25. When it is no and yes, which is a false, you are getting 10. When it is a yes and no, you are getting 6, which is also a false. So basically 20, 25 are the correct prediction. Exactly. True. David, what you said is correct. So you're marking them as negative. Correct. Which is not correct. So the result telling us what we have, 20, 25 is correct prediction, 10 plus 6 is incorrect prediction. So here when you have 10 plus 6 incorrect prediction, so you take 20, 25 by total, that will give you the accuracy. Cool. Getting all of it. So now do the same prediction report. Try to type this, right? So if you generate this one, you can see in confusion matrix, if you can see, you saw you had some values, right? So you can see here accuracy, F1 score, all these things. So these are some of the important things that are required whenever you're building a model to check the performance of your model. So basically, a classification report will give you all this. So you can see precision, recall, F1 score, all these things. Accuracy, all of you know, it is like 74%. So this complete report it will generate, right? So this is something which I wanted all of you to understand. Is this fine? Getting it, all of you? Is it good? Some people getting different accuracy because sampling might have become a little different. So that's okay. So this report will give you the F1 score, confusion matrix, all these things I showed you in this particular link. I told you these things can be calculated, right? So you can see F1 score, accuracy, precision, all these things. So there's no need for us to calculate all of them. So there is a function that will give you that, which is your classification report. Cool, fine. Let us say, for example, how do I explain? Okay, so what basically macro average is a problem that comes in when you have multiple sets of binary predictions. So I mean it has a, whenever you have a multi-class prediction, right? So you have multi-class predictions, whether you, I mean, here you have 0 and 1, but let's say you have 0, 1, 2, 3, 4, which is a multi-class prediction. Now macro average, what it does is it will bring down your multi set of binary, I mean multiple predictions into a multiple set of binary predictions, calculates the corresponding metrics for that binary cases, and then averages it. Let us say for example you have 0, 1, 2, 3, 4, 5, 6. It will take 0, 1, 2, 4, 5, 6, like that binary it will take, and then it will take an average and it will give you. So that is your macro average. So weighted average is nothing but few variables will get more weight, few variables will get less weight. So that is something. So all these things are here: support, confidence, F1 score. Yeah, since it is binary, we are getting the same thing. You can see all the things that are mentioned are here. So that depends on what business value that you want. So F1 score is a harmonic mean between your precision and recall. So what is precision? What is recall? True positive rate, false positive rate. Out of them, how many true, how many false? So all these things are here. So that's why I gave you this link. This will give you a complete understanding of the confusion matrix, which is required. So this is something that you can explore, right? Now, last but not the least, I don't want you to type this. I just want only to understand it. I have something called as a ROC curve. So ROC curve stands for a receiver operator characteristic curve. So ROC means receiver operator characteristic curve, right? So now how am I going to use this particular receiver operator characteristic curve for my analysis is what we are going to see. Cool. So we are just going ahead and then we are just trying to do it for our analysis, and then we will understand how we are exactly doing it, right? Slowly we will see how exactly an ROC curve is constructed. So if we can observe this ROC curve, how exactly it comes is, just hold on. So basically, whenever you have this particular ROC curve, how we are going to use it, or probably how we are going to construct it, is something we will see now, right? So whenever you have your data, you will have two things, right? So you have positives, you have negatives. Now whenever you have a positive or a negative for that matter, so there are two things that you can do. So what are those two things? You can find out a false positive rate and a true positive rate, right? So there are two things that happens: false positive rate and true positive rate. Now having said that, so with the false positive rate and true positive rate, you are plotting a graph. So based on the understanding of this, you are plotting a false positive rate and a true positive rate. So when you construct a graph like that, the red line what you're giving is like a baseline, which means the blue line what you're checking there on the top should not go below that. So that is something that is there. Now having said that, whenever you get to see a ROC curve like this, you will be able to identify how my model is performing. So if your blue line and red line, blue line is almost near to the red line, which means my model is not so good model. The far away the blue line is, the better the model is. So that is something which you can probably conclude by this. So this is ROC curve, which will help you to analyze your model better. So the far the ROC curve, the better the model is, right? So this is something I wanted to tell you. Is this fine? Are you understanding it? This is like basic things I'm telling you, not complicating it much. Sure. So basically what we are trying to achieve in this is very simple. So you can see, so I'll explain you this and then we will see. My scale and metrics, again, we're taking and ROC curve. So these are also in bit, which is your 0 to 1, right? So which is 0 to 1, which means this is your, so what we're trying to do here is, this is like a template, you can use it. So from here to here, what you're trying to do is just plotting this one. So your plot dot figure, you're plotting your values, right? So 0, 1, 1, 2, all these things is your x limit, y limit, which means the axis from where to where you want your x axis to be. Title, legend, all these things you are giving. Now, the main thing that you're supposed to do is only two lines. So these are the two lines. What you are getting here. So ROCAUC, this is for the blue line, logit ROCAUC. So this one you will find out by using the ROCAUC score function from your sklearn metric. Then you have FPR, TPR, threshold, all these three things you will again get from the ROC curve function. So these lines you need to just remember. No need for you to by heart or maybe remember exactly. This you can use it as a template whenever you are trying to whenever you're trying to implement a logistic regression model. You can use this template and then you will be able to get the same kind of graph. So these are not required to understand. So you're predicting probabilities of X test. So whenever you use X test, no, in the last one is your target. So you're taking that one only, nothing else. Cool. All of you are getting an idea about all these things, whatever we discussed now. So you read the data, you explored it, you understood whether it is imbalanced or not, right? And then you understood the difference between this. You saw whether it is imbalanced or not visually. And later what we did is like we splitted the data into training and testing data set, and then training and testing data set, then you made a X train, Y train, Y train, X train, right? So these things we understood. Then you built a basic train model. So basic train model, you trained it, and later you predicted it. Training and prediction. Once you do that, you found out accuracy. So one is the log model accuracy. This you can use, or we need to use confusion matrix. So we understood how a confusion matrix works, and also classification report. So confusion matrix is important. So this one you are going to use for our plotting the ROC curve. So I told you what is a basic ROC curve, and then you'll be able to understand. It should not be -1 because you're just taking the log model predicted probabilities. So whenever you just take this log model predicted probabilities, it will give you a term. I don't know whether it will print or not, but I will show you. You can see there are two things in this. So that is the reason why you're taking the second one. True? Nice. So this is internal, so you can use it as a template. Save fig, what it will do is it will save your ROC curve. So somewhere it will save it. Yeah, you can see. Save fig will save your ROC curve. You can see this, you can put it into your PPT or wherever you want to give a presentation. There you can use it. So we're just basically saving it. That's it. Cool.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now that we have come to the end of the session, please subscribe to our channel and hit the bell icon so that you never miss any update from Intellipaat. Also, if you have any queries, then put down in the comment section and we will be happy to answer those. Thank you for watching.